This is a general English question. We have been given an incomplete statement and we need to fill in the blank to complete it from the given options. The man who is now municipal commissioner worked as dash. Now looking at the options, we get an idea that this man worked as security guard at some university. We just need to apply the appropriate articles before them to make the sentence meaningful and grammatically correct. Now looking at the security guard, it is not beginning with a vowel, so we'll either use a or the before it, and the one which suits best in this particular context is a. That man worked as a security guard, so here we'll go with a. And coming to university, u is a vowel, but there are some exceptional cases such as this university where we use the even before the vowel sound, just as we have the USA. In the similar sense, we use the university. So here the appropriate choice would be the man who is now municipal commissioner worked as a security guard at the university. So the correct option is B. This is a general English question. We have been given a statement. Nobody knows how the Indian cricket team is going to cope with the difficult and seamer-friendly wickets in Australia. Choose the option which is closest in meaning to the underlined phrase cope with in the above sentence. Now, this cope with basically means how to deal with someone in a particular way, or how to win against somebody, or how to adjust with someone. So the one out of the given options which will be in closest meaning with this phrase cope up is put up with. Means I don't know how will I put up with you. Means I don't know how will we both carry on together. So this put up with phrase is similar in meaning with this cope up, so we can replace them with each other, and that is the best suitable option in this case. So we shall go with option A, put up with. This is a general aptitude question. We need to find the odd man out among these four words: mock, deride, praise, and jeer. Now this first word mock means to laugh at somebody or make fun of someone, so that is in a negative sense. And on similar lines is the next word deride, which means to ridicule somebody, make rude comments about someone, or laugh at them. So again, these two are on the same lines, and that is the case with the last word jeer as well, which means to making negative comments about somebody or talking in a negative way, so that can hurt someone. So all these three words are in the negative sense, but this particular word praise means a warm approval or a heartfelt appreciation for someone. So this word is different from the other three, and that will be taken as the odd man out. So the correct option is C, praise. This is again a general aptitude question in which we need to find the odd man out from these options. The first one is C, A, D, B, E. Let us check if we can find out some pattern in these letters. As we can see, this C and D are consecutive, then this D and E are consecutive. Similarly, A and B are consecutive. So here alternate letters are forming a chain. Let us see if this pattern is being followed in other options. Next one is J, H, K, I, L. Again here we have the chain J, K, L and H, I. Those are two consecutive chains. Let us also check option C, X, V, Y, W and Z. Here we have a chain X, Y, Z and VW. Now the last one is O, N, P, M, Q. Here OP are consecutive, PQ are consecutive, but this N, M are not consecutive. It must have been MN, then it would satisfy. In this case, this option D is disqualified, and that would be found as the odd man out because it is not following the pattern as other three. So the correct option will be D. This is a mathematical aptitude question. They are talking about a quadratic equation in which the product of the roots alpha and beta is 4. So the roots are alpha and beta. Their product is 4. We need to find the value of the given expression. Alpha raised to n plus beta raised to n upon alpha raised to minus n plus beta raised to minus n. You can rewrite this as alpha raised to n plus of beta raised to n 1 by alpha raised to n plus 1 by beta raised to n. Now cross multiplying these on both sides, we get alpha raised to n plus beta raised to n. Taking that LCM, we again get the same thing over here, and their denominator will be alpha raised to n, beta raised to n. Now these two things get cancelled out with each other, and what we get as a result is simply alpha raised to n, beta raised to n, because this is the denominator of the denominator, so that will come forward, and the result will be simply alpha beta the whole raised to n. And we already know that the product of roots alpha beta is 4, so this expression simply becomes 4 raised to n. So that is the correct answer, option B. This is a set theory question which can be solved by making the Venn diagram. It is talking about an institute in which the faculty members are connected with each other using either Facebook or WhatsApp. So we can map this thing using the following Venn diagram for Facebook and WhatsApp. It is saying that 55 are connected with each other through Facebook. Now this 55 will also include some of the common members which are connected using both Facebook as well as WhatsApp. So over here we will have 55 minus x, which means those faculty members which are connected only with Facebook. And next they are saying 85 are connected through WhatsApp. Again these 85 will include this x, because when faculty is using both Facebook and WhatsApp, then it will be counted on either sides. Hence we need to subtract this x, and we shall write 85 minus x in this region corresponding to the members who are using only WhatsApp. Now 30 faculty members do not have Facebook or WhatsApp accounts, which means this is our universal set, and over here we write 30, which means those faculty members who use neither Facebook nor WhatsApp, and the total they have already given to be 150. So we need to determine the number of faculty members connected only through Facebook accounts, which means we need to determine the value of this 55 minus x. Now summing all these together, we must get 150, including the faculty members who use Facebook, WhatsApp, both or none. All of them will sum up to 150. So let us form that equation: 55 minus x plus 85 minus x plus 30 equal to 150, which means Facebook faculties, WhatsApp faculties, those who use both and those who use none, all of them will sum up to 150. Now we cancel out these x and we get 55 plus 85 plus 30 minus x equal to 150. Now summing this up, we get 140 plus 30, 170 minus x equal to 150, which means the value of x is 20. So there are 20 faculty members who are connected using both Facebook as well as WhatsApp. So the value of x is 20. Here we shall have 55 minus x means 35, 85 minus 20 equal to 65. They have asked us for those members connected only through Facebook, so that will be this particular value, 55 minus 20, which is 35. And the correct answer is option A, 35. This is a reasoning based question. We have been given a paragraph, and based upon that we need to check which of these two inferences can be drawn. The paragraph is saying that computers were invented for performing only high-end useful computations. However, it is no understatement that they have taken over our world today. The internet, for example, is ubiquitous. Many believe that the internet itself is an unintended consequence of the original invention. Here author is trying to convey some negative thoughts about internet. He is trying to say that computers were invented purposefully for performing some useful computations, but internet as a result was not required. It was unintended and it happened accidentally. Next, he is saying that with the advent of mobile computing on our phones, a whole new dimension is now enabled. One is left wondering if all these developments are good for, or more importantly even, required. Again, he's having a negative taste about mobile computing as well, trying to say that I'm left wondering if these developments, which developments, internet and mobile computing, if they are good for or more importantly even required. So he doubts the existence of all these technologies. He just says that computers were invented for purpose, but these two things, internet and mobile computing, are he's doubtful about. and he's having some negative thoughts about them. So let us see now which of these statements can be inferred. The author believes that computers are not good for us. No, he's trying to convey the idea that they were invented for some high-end useful computations only. So this statement cannot be inferred. Next is mobile computers and internet are both good intended inventions. About internet, he's saying that no, internet was unintended. But this statement is saying that they were intended inventions. So again, this statement is also incorrect. It is not getting inferred from this passage. So we shall go with option D, neither 1 nor 2. That is the correct option. This question is based upon syllogism. It is stating a fact that all hill stations have a lake. So we can interpret this using the Venn diagram as follows. We have hill stations and lakes. If all hill stations are having a lake, we can say these are the hill stations and these are lakes. So all hill stations are coming inside the lakes. Now next is Ooty has 2 lakes. So we can say that this is Ooty and it is having 2 lakes like this. Which of the statements below are logically valid and can be inferred from these sentences? Ooty is not a hill station. Now it is saying that all hill stations have a lake, which means they have at least 1 lake, while more are also possible. Now this Ooty is having 2 lakes, we know that for sure. Does that mean Ooty is also a hill station? That is may or may not be correct. It is possible that this Ooty is like this, it is also intersecting with the hill stations, but that is just a possibility. It is not compulsorily being conveyed from the given sentences. So we will not go with this option. Second one is saying that no hill station can have more than 1 lake. Now this is also not being said. They are just saying all hill stations have a lake, which means there is at least 1, more are also possible. So if this particular hill station is there, it is having multiple lakes. That is a possibility, definitely. So again, this sentence saying that no hill station can have more than 1 lake, which means all have either 0 or 1, is also incorrect. So none of these two inferences are being drawn from the given passage. So we shall go with option D, neither 1 nor 2. This is a general aptitude question. Given this 2x4 rectangular grid, we need to identify the total number of rectangles hidden inside this figure. So basically we need to understand one fact that every square is also a rectangle. So if we take this 1x1 grid, then even that will be counted as a rectangle. So in order to get the total number of rectangles in this figure, what we need to do is first let us understand the definition of a rectangle. It is a four-sided closed figure, first of all, a quadrilateral in which the opposite sides are parallel. So, and there is a right angle definitely. So basically we need a pair of horizontal lines and a pair of vertical lines. Let us say these horizontal lines H1, H2 and the vertical lines V1 and V2. That will definitely form, these 4 lines will form one rectangle having the dimensions mod of V1 minus V2 into mod of H1 minus H2. So all 4 lines picked up in this particular fashion will give us one rectangle. Hence the total number of rectangles in this figure will be the total number of ways in which we can select these 4 lines. So over here we have 1, 2 and 3 horizontal lines, and similarly we have 1, 2, 3, 4 and 5 vertical lines. So for forming one rectangle, we need 2 vertical and 2 horizontal lines. So from these 3 horizontal lines, we can pick up any 2 using 3C2. And similarly for vertical lines, out of these 5, we can pick any 2 using 5C2. All of these will give us one rectangle each. Hence the total number of rectangles will be the value of this particular expression. And that would be 3 into 10, which is 30. So basically there are 30 rectangles hidden in this figure. And how did we find that? Found that using this particular expression by choosing 2 vertical lines and 2 horizontal lines, and they would definitely intersect each other, forming a 4-sided closed figure which would be a rectangle. So in total we have 30 rectangles. So going with option C. This question is based upon simple geometry. We have been given a graph in which there are two intersecting lines. Let us call them L1 and L2, intersecting at point 1, 2 and passing through 3, 0, minus 3, minus 2. We need to determine the equation corresponding to this graph. So first of all, for line L1, let us say its slope will be 2 minus of minus 2 upon 1 minus of minus 3. So it is 1 and it passes through the point 1, 2. So using slope point form, we'll find its equation to be, it satisfies this particular point. So we'll have 2 equal to x plus c. In place of x, we'll write 1. So we get the value of c as 1. M is also 1. So equation is y equal to x plus 1. Now for this line L2, we have the slope as 2 minus 0, 1 minus 3, that is minus 1. And it satisfies the point 1, 2 as well. So we'll put 2 equal to m minus 1 plus c. So here the value of c is 3 and the equation we get is y equal to mx plus c. So minus x plus 3. So we get the two expressions as y equal to 3 minus x and y equal to 1 plus x. Now we need to convert these both into one common form using a modulo so that the given option will satisfy both these lines together. So 3 minus x and 1 plus x, we can break this as something like as given in let us say we break this with 2 and keep the things separate. Let us write this 3 as 2 plus 1 and then minus x, and this equation as 2 minus 1 plus x. Now let us try to encapsulate this 1 and x into a modulo. So this will give us 2 plus 1 minus x, and this is giving us 2 minus of, if we take that minus out, then we shall get again this particular thing as 1 minus x. When we open this, it will become 2 minus 1 plus x, so corresponding to this equation of line 2. So we can see that in the option C, 2 minus of modulo x minus 1. Once if we open this with positive sign, then we shall get 2 minus x plus 1, which will be 3 minus x, corresponding to the line L2 which we got over here. And when we open it with a negative sign, we will get 2 minus of, which will convert into plus x minus 1. So that will become 1 plus x. So corresponding to this line L1. Hence this particular equation represents both these lines. When we open this with positive and negative sign, that's why they have put a modulo over there. And hence this is the equation which represents the given graph. So the correct option is C.
Consider the following expressions: 1 false, 2 Q, 3 true, 4 P or Q, 5 negation of Q or P. The number of expressions given above that are logically implied by P and P implies Q is dash. So this is a question from propositional logic. Here they have given us this expression and they are asking us which of these is logically implied by this. So you need to note that they are asking which of the options are logically implied by this, and they are not asking which of these are logically equivalent to this. So to find out which of these are logically implied by this, it means that we need to take this as a tautology. That means this is always true. So if this is always true, which of these will also be true? That will be logically implied by this. So we can try to simplify this. P and P implies Q, we can write as P and negation of P or Q, which will be same as P and negation of P or P and Q. P and negation of P is 0 always. So it will be P and Q. So P and Q is always true, which means that P is 1 and Q is 1. Now let's take a look at the options. False is false because this is always true. So this is false. Q is true. If P and Q is true, Q is 1. So this is correct. True is correct because this is always true. P or Q is also correct because P is 1 and Q is 1, meaning P or Q is true. negation of q or p. It's q or p is there, p is 1, so this expression is also true. So out of these you can see that 4 of these will be logically implied by p and pw implies q. So the answer is 4. Let f of x be a polynomial and g of x equals f dash x be its derivative. If the degree of f of x plus f of minus x is 10, then the degree of g of x minus g of minus x is dash. So this is a question from engineering mathematics. Even though it might look a bit complex, it's a very easy question. So let's take a look here. So it's given that f of x plus f of minus x is 10. The degree of f of x plus f of minus x is 10. So let's take some sample f of x which has a degree of 10. I will take the simplest function, that is f of x equal to x raised to 10. It has a degree of 10. Now f of minus x will be, substitute minus instead of x here, substitute minus x instead of x, but instead degree is even, f of minus x will also have the same value, that is x raised to 10. So f of x and f of minus x equals x raised to 10. Now f of x plus f of minus x will be f of, that is x raised to 10 plus x raised to 10, that is 2 into x raised to 10. Again this has a degree of 10 only. So now this satisfies, this f of x satisfies the condition in the question that f of x plus f of minus x is 10. Now let us try to calculate what g of x minus g of minus x will be. G of x will be f dash x, that's equal to 10 x raised to 9. That's the derivative of x raised to 10. Again g of minus x will be, substituting minus x instead of x here, that will be minus 10 x raised to 9. And g of x minus g of minus x will be 10 x raised to 9 minus 10 x raised to 9, that is 20 x raised to 9. That has a degree of 9. So g of x minus g of minus x will have a degree of 9. So we got one example which satisfied this condition, and from there we got the answer. So you can try to prove this, that this will always be the case for whatever function f of x we take, but then we don't need that for gate. If we can find one example which works all the condition in the question, that will be the answer. So here the answer is 9. The minimum number of colors that is sufficient to vertex color any planar graph is dash. So this is a question coming from graph theory regarding graph coloring. So what is graph coloring? Graph coloring or vertex coloring means that we need to give every vertex in a graph some color such that no two adjacent vertices will have the same color. For example, if you take a look at this graph here, let us say I give this vertex color 1, which means I will have to give this vertex some color other than 1 because this is adjacent to this vertex here. So let us say I give this a color of 2. Now if you take a look at this vertex, this is adjacent to this as well as this, so it should have a color different from 1 and 2. Let us say I give this a color 3. Now in this way I have colored all the 3 vertices in the graph such that no two adjacent vertices have the same color. Now this is graph coloring. Similarly, if I have a graph like this, you can see that if I give this vertex color 1, this is adjacent to this, so I should give it color 2. This is adjacent to both of these, so I will give it a color of 3. Now this node is adjacent to all 3 of this, so this will, I will give it a color of 4. So this graph I need 4 colors to color it correctly. Now the first thing you learn about graph coloring is that any planar graph can be colored using 4 different colors. Any planar graph is 4 colorable, and they are asked us that question straightforward here. The minimum number of colors that is sufficient to vertex color any planar graph. So from theorem that is 4 only. Consider the systems each consisting of m linear equations in n variables. 1. If m is less than n, then all such systems have a solution. 2. If m is greater than n, then none of those systems have a solution. 3. If m equal to n, then there exists a system which has a solution. Which of the following is correct? And 4 options have been given. So this is a question coming from linear algebra. Here they have given systems have each consisting of m linear equations in n variables, and for each of these 3 conditions they are asking which of those systems will have a solution. Now this is not just like solving a system of m linear equations and n variables. We can't directly use the formulas we learned there here because this question is given in a bit of a tricky way. So we'll go through the statements one by one and see what the answer is. 1. If m is less than n, then all such systems have a solution. Now let us consider a system where m equal to 2 and n equal to 3. M is less than n, so it satisfies the case for system 1. Now it says M is the number of linear equations and n is the number of variables here. So for m equal to 2 and n equal to 3, it means there will be 2 linear equations in 3 variables. Now consider these 2 equations. X plus y plus z equal to 5. X plus y plus z equal to 6. Now clearly this system is inconsistent because at the same time I am saying x plus y plus z is 5 and also x plus y plus z is 6. There is no way I can solve for this system of equations. So saying that if m is less than n, all such systems have a solution is false. Because these 2 equations were inconsistent. That's why I could not solve for this. If these were consistent equations, then I could have got infinitely many answers to this, since the number of equations were less than the number of variables. But I can always take 2 inconsistent equations like this, and for this there will be no solutions. So statement 1 is false. Statement 2, if m is greater than n, then none of those systems have a solution. So let's take m equal to 3 and n equal to 2 here. That is, we have 3 linear equations in 2 variables. Now let us consider this system. X plus y equal to 4. 2x plus y equal to 6, 2x plus 2y equal to 8. Now if you take a look at these equations, you will see that this has a solution where x equal to 2 and y equal to 2. If x equal to 2 and y equal to 2, x plus y is 4, 2x plus y is 6 and 2x plus 2y is 8. But the number of equations were greater than the number of variables here. And still we got a solution because if you take a look, these 2 equations are actually linearly dependent. In the question they had not given that the equations, the m linear equations were linearly independent or anything. We can always take 2 linearly dependent equations like this. So here the number of equations were greater than number of variables and still we got a solution, and which means that statement 2 saying that none of those systems have a solution is also false. We cannot, if m is greater than n and if the linear equations are dependent, then we will have a solution. Now statement 3, if m equal to n, then there exists a system which has a solution. Now that is clearly true. If m equal to 2 and n equal to 2, let us say, and if equations are x plus y equal to 4 and 2x plus y equal to 6, I can again solve for this as x equal to 2 and y equal to 2. So clearly I have given an example where m equal to n and there exists a solution. There exists a system which has a solution. So statement 3 is correct. If they were saying that if m equal to n, then every system has a solution, then this statement would have been false. But they just said there exists a system. So statement 3 is correct. So looking at options, you will see option C is the right answer. Suppose that a shop has equal number of LED bulbs of 2 different types. The probability of an LED bulb lasting more than 100 hours, given that it is of type 1, is 0.7, and given that it is of type 2 is 0.4. The probability that an LED bulb chosen uniformly at random lasts more than 100 hours is dash. So this is a very simple question coming from probability theory. So first of all we will find out, let us say P of choosing a bulb of type 1, that's equal to P of T1. Now that will be 0.5 because it's given that there are only 2 types, type 1 and type 2, and probability we are choosing a bulb uniformly at random, and there are equal number of type 1 and type 2 bulbs. So the probability of choosing a bulb of type T1 will be 0.5. Similarly, probability of choosing a bulb of type T2, P of T2, will be also equal to 0.5. Now the final probability that they are asking is the probability that a chosen bulb lasts for more than 100 hours. That will be equal to that. So there are 2 ways of choosing, right? First we will choose a bulb of type T1 and then the probability that it lasts greater than 100 hours, or we choose a bulb of type T2 and then it lasts for greater than 100 hours. So the total probability that a bulb chosen lasts for greater than 100 hours will be equal to probability that we are choosing a bulb of type T1 into probability that the T1 type bulb lasts greater than 100 hours plus probability of choosing a bulb of type T2 into probability that that chosen bulb T2 lasts greater than 100 hours. So that will be equal to 0.5 into 0.7, this is given in the question, plus 0.5 into 0.4, this also is given in the question. That's equal to 0.35 plus 0.2, that will be 0.55. That's the final answer. Suppose that the eigenvalues of matrix A are 1, 2 and 4. The determinant of A inverse transpose will be equal to dash. So this is a question coming from linear algebra. So I have written 2 theories from linear algebra here. If a matrix A has an eigenvalue lambda, then the inverse of the matrix A inverse will be having the eigenvalue as 1 by lambda. Also 2, determinant of A will be equal to the product of eigenvalues of matrix A. Now let's look at the question. They are asking us to find out determinant of A inverse transpose. Now determinant of a transpose of a matrix and the matrix itself will be same. So this we can rewrite as determinant of A inverse. Now we know the eigenvalues of A inverse will be 1 by the eigenvalues of the matrix A. That's coming from this theorem. So the matrix A had eigenvalues 1, 2 and 4. So the eigenvalues of A inverse will be 1, 1 by 2 and 1 by 4. Which means that determinant of the matrix A inverse will be the product of the eigenvalues. That's coming from theorem 2. That's equal to 1 into 1 by 2 into 1 by 4. That is 1 by 8 or 0.125. Here we had shown that the answer was determinant of A inverse only. Determinant of A inverse is 0.125. That's the answer. Consider an 8-bit ripple carry adder for computing the sum of A and B, where A and B are integers represented in 2's complement form. If the decimal value of A is 1, the decimal value of B that leads to the longest latency for the sum to stabilize is dash. So this is a question regarding ripple carry adders coming from digital logic section. In the question they have given an 8-bit ripple carry adder and we are adding two numbers A and B, where A is equal to 1 and they are asking for what value of B it will lead to the longest latency for the sum to stabilize. Now let's take a few examples and see how much time it takes for the sum to stabilize. It's an 8-bit ripple carry adder, so A will be 0 0 0 0 0 0 0 1. Let us consider a B of value 0 0 0 0 0 0 1 1. So when we are adding this, we will be adding first 1 and 1, which will be 0 with a carry of 1. Then we will be adding 1 and 1 again. It will be 0 with a carry of 1 here, and then we will be adding just 1 here, so it is 1. So after 3 steps we got the sum 1 0 0. In all the rest of the steps we will be just putting zeros at the end. So we know that the sum we got after 3 steps only, or after 3 steps only the sum is stabilized here. So now we need to increase the number of steps to the maximum. Okay, so let's take another example. Let us say the least significant bit in B is 0. In that case there won't be any carry generated in the first step, right? So 1 plus 0 will be 1. There is no carry generated. So there is no carry generated means in the rest of the steps all the digits in A is 0 and all the digits in B will be 0 or 1. So there will never be any more carry generated, meaning whatever was the value for the bits in B, we will be just writing the same, because for A it is all 0. So at max, even if we take the number 1 1 1 1 1 1 1 0, still there won't be any carry in any of the additions, and at max it will take 8 steps to stabilize. In this particular example it is taking what, 1 1 0 1 1 1 1 0 0 1, that is 5 steps after which the sum is stabilizing. So even if we take the number 1 1 1 1 1 1 1 0, in that case also at max it will take 8 steps only for the sum to stabilize. Now if you are making everything as 1, let us say, in this case see 1 plus 1 we are doing, that will be 0 with a carry of 1. Now there is a carry generated here. Again we are doing 1 plus 1 only, that is 0, again a carry is generated. So this will keep on happening till the end. At the end also it will be 1 plus 1, which is 0, and a carry is generated. So we need to put that carry also to the sum here, which means that here for the sum to stabilize it will take 8 steps plus 1 additional step for the carry part. So here we took 9 steps for the sum to stabilize, and this is the maximum. We can't get more than 9 steps for the sum to stabilize, and there is only one number which will generate 9 steps, that is 1 1 1 1 1 1 1 1 for B. Now this number is nothing but minus 1 in 2's complement form. So they were asking us the decimal value of B. So the answer is minus 1 here. Let x1 XOR x2 XOR x3 XOR x4 equal to 0, where x1, x2, x3, x4 are Boolean variables and this is the XOR operator. Which one of the following must always be true? And 4 options are given. So in this question they are saying that x1 XOR x2 XOR x3 XOR x4 equal to 0. So we will give one sample assignment which will make it true. If we assign x1 equal to x2 equal to x3 equal to x4 equal to 1, now this will become 1 XOR 1 XOR 1 XOR 1, which is 0 only. So 1 1 1 1 satisfies the condition given in the question. Now let's look at the options. It is saying that A, x1 x2 x3 x4 equal to 0. Clearly x1 x2 x3 x4 here is 1. So saying that this is always true is false. If you look at option B, x1 x3 plus x2, clearly x2 is 1 here, so whatever plus x2 will be 1 only here. So again saying that this is 0 is also false. If you look at D, it's saying that x1 plus x2 plus x3 plus x4 equal to 0. Again, with the same example only, we can show that this is also false. If all are 1, then x1 plus x2 plus x3 plus x4 will be 1 only. So now C is the only remaining answer, and that's the correct answer. I will prove that it is right as well. So x1 XOR x2 plus XOR x3 XOR x4, we can rewrite it as x1 XOR x3 XOR x2 XOR x4 equal to 0. Even if we rearrange x's in this expression, the value won't be changing. Now x1 XOR x3 will be same as x1 complement XOR x3 complement. You can draw the truth table and verify that. So x1 XOR x3 XOR x2 XOR x4 equal to 0. I can rewrite it as x1 complement XOR x3 complement XOR x2 complement XOR x4 complement. This is because A XOR B will have the same value as A complement XOR B complement. Now if you see, this XOR this will be equal to 0, meaning this part should be equal to this part. Either this is 1, if this is 1, then this should also be 1, making 1 XOR 1 0, or if this is 0, this should also be 0, making 0 XOR 0 equal to 0. If these have different values, 1 and 0, the XOR would be 1 only, which won't satisfy this. Now this is exactly what's given in option C. x1 XOR x3 x1 complement XOR x3 complement equal to x2 complement XOR x4 complement. So C is the right answer. Let x be the number of distinct 16-bit integers in 2's complement representation. Let y be the number of distinct 16-bit integers in sign magnitude representation. Then x minus y is dash. So this is a question coming from number systems. They are asking us about sign magnitude representation and 2's complement representation of 16-bit integers, and they are asking us how many numbers each of these can represent and what the difference between the number of numbers which each form can represent is. So let's take a look at sign magnitude representation. How sign magnitude representation works is, the first bit will be the sign bit and the rest of the bits will be the magnitude bits. So if you see, the range of numbers will be, the smallest negative number would be, here we have a 1 showing negative number, and then the rest would be 1 1 1 1 1. That will be the negative number minus 2 power 15 minus 1. Up to, it will go up to minus 1 and then 0, and then positive numbers will start when the sign is 0, sign bit is 0, and then the largest positive number will be here, sign bit 0, and then there are 15 ones. That will be the number 2 power 15 minus 1. So the range is minus 2 power 15 minus 1 to 2 power 15 minus 1. But in 2's complement representation, the range of numbers, if you are using 16-bit integers, is minus 2 power 15 to 2 power 15 minus 1. Now if you see, there is one additional number in 2's complement representation. How this one additional number came is, in sign magnitude representation, 0 and the rest of all zeros as well as 1 and rest of all zeros both represent the same number, that is 0 only. So for 0 only we are using 2 representations in sign magnitude representation. But in 2's complement representation, this number will be 0, but this number will be that one additional number which was not there in sign magnitude representation, that is minus 2 power 15. The number minus 2 power 15 was not there in sign magnitude representation. So clearly this is x, this is y. There is one additional number in x compared to y. So x minus y will be equal to 1. 1 is the answer. A processor has 40 distinct instructions and 24 general purpose registers. A 32-bit instruction word has an opcode, 2 register operands and an immediate operand. The number of bits available for the immediate operand field is dash. So this is a very simple question coming from computer organization regarding machine instructions. So here they are saying that we have 24 general purpose registers, which means for denoting a register we need to allocate 5 bits in the instruction. That's because 2 power 4 is 16, that is less than 24, that is less than 2 power 5, which is 32. Similarly, we have 40 instructions. So 40 instructions, for representing that we will need 6 bits. That's because 2 power 5 less than 40 less than 2 power 6. Now if a machine instruction looks like this, the first part will denote the instruction, and then we have another part for denoting register 1, then we have another part for denoting register 2, then the last part will denote the immediate operand. That's what given in the question, right? Instruction has an opcode, 2 registers and an immediate operand. This is the opcode. Now the opcode part will need 6 bits, which we calculated here. Register 1 and register 2 will need 5 bits each. So how many bits are remaining for the immediate operand? So the total size of instruction was 32 bits. So out of 32, 6 plus 5 plus 5 is already used up, meaning 16 is used up. So the remaining is 32 minus 16, that's equal to 16, meaning we have 16 bits available for the immediate operand. 16 is the answer. Breadth first search is started on a binary tree beginning from the root vertex. There is a vertex t at a distance 4 from the root. If t is the nth vertex in this breadth BFS traversal, then the maximum possible value of n is dash. So this is a question from data structures regarding breadth first search. So the property of BFS is that first we will traverse the root node. After that we will traverse the nodes at distance 1 from the root. And after that we will be traversing the nodes at distance 2 from the root, etc. That will go on. Now let's take a look at this complete binary tree. In the question they were asking us about binary trees. Okay, so let's take a look at this complete binary tree. So if you are doing a BFS traversal on this, so first node that will be traversed will be the root node. So this is the first node that is traversed. After that, nodes at distance 1 will be traversed. So this node and this node will be traversed in some order. But there are two nodes here. So the second and third node will be one of these nodes only. After the second and third node, both these nodes will be traversed completely. After that, nodes at distance 2 will be traversed. That is these 4 nodes. Meaning the nodes that is traversed, the 4th node up to the 7th node will be one of these 4 nodes. So after 7 nodes are traversed, all these 4 plus this 2 and this, all these will be traversed. After that we will be traversing nodes at distance 3. So these 8 nodes will be traversed after that. Meaning already there were 7 nodes, meaning node 8 up to 15 will be these nodes. After that nodes at distance 4 will be traversed. There are 16 nodes here. Meaning nodes starting from 16 up to 31 will be one of these 16 nodes. Now our node was at a distance of 4 from the root, meaning our node was one of these nodes. Meaning if we have a node t at distance 4 from the root, it will be traversed as either 16th or 17th or 18th, etc. up to 31 node. So that node will be the 16th, from 16 to 31. In this range that node will be falling if that is the nth node that is traversed. So you can see the maximum will be 31. So the maximum value of n here will be 31. Now this was a complete binary tree, right? Even if this is not a complete binary tree, if it's not a complete binary tree, then you will see that this range values will only decrease and not increase. For example, if I had only one node as the one node at distance 1, then this will be the first node to traverse, this will be the second node to traverse. Now the third node to traverse will be in a range from 3 to 4 and not in a range from 4 to 7 like we have here. So if it is not a complete tree, the range values will be decreasing only. So we'll have maximum range when it is a complete binary tree, and also that node at distance 4 is the last node that is traversed in distance 4 nodes. That will be 31. 31 is the answer. The value printed by the following program is dash, and we have been given a program here. So this is a very simple C programming question where they are testing us whether we know the concept of pass by value and pass by reference. Okay, so let's take a look at the main function. In the main function we are declaring two integers I and j, where I equal to 5 and j equal to 10. Let this denote the variables I and j. I has value of 5, j has a value of 10. Let I be at address 100 and j be at address 200. Okay. Now to the function we are passing I by reference and j by value. So when we are passing I by reference, here we will be passing the address of I here to the pointer p, and we are passing the value of j to the integer m. So we will construct p and m as well in the function. We have p, we have m. Let p be at some address 1000 and m be at some address 1100. Now p will have the value of address of I. Address of I was 100, so p's value will be 100, and j and m will have the same value as j because we are passing j by value. So j's value was 10, meaning m will also have the value 10. Now we are doing m equal to m plus 5, meaning m's value becomes 15 here, and star of p equal to star of p plus m. Now p had the value of 100, Star of P means the value at this address 100. At this address 100, we have nothing but the variable I. So when we are changing the value of the address 100, we are changing variable I only here. So variable I becomes variable I plus the value of M. Now that is 5 plus the value of M is 15. Now 5 plus 15 is 20. So I's value becomes 20 now. After that we are returning from this function. Now coming here we are printing the value of I plus j. Now I is 20, j is 10, so the total is 20 plus 10, that's equal to 30. 30 is the right answer. Assume that the algorithms considered here sorts the input sequence in ascending order. If the input is already in ascending order, which of the following are true? 1. Quicksort runs in theta n square time. 2. Bubble sort runs in theta n square time. 3. Merge sort runs in theta n time. 4. Insertion sort runs in theta n time. And 4 options are given. We need to find out which of these statements are true. So this is a question regarding sorting algorithms. So we will go through these statements one by one. If you take a look at statement 4, it says that insertion sort runs in theta n time. Now that is true. The best case running time of insertion sort is theta n when the array is already in sorted order. Why that happens is, what we do in insertion sort is for I equal to 1 to n, for each element a of I, we will assume that the array to the left side of a of I is already sorted, and we will try to place a of I in some position in the left side array to the left side of a of I, such that it will be in the sorted position. Now if the array is already in a sorted order, we don't need to make any changes for each element a of I that we are choosing. So we will only do one sweep of the entire array, and we won't be making any changes in that sweep. So it runs in theta n time. So saying that insertion sort runs in theta n time is true. Yes, that is the best case of insertion sort. Then that happens when the array is sorted. 2. Merge sort runs in theta n time. Now that is false. Even the best case of merge sort algorithm is theta of n log n. Now saying that merge sort runs in theta n times is false, because whatever options, even if the array is sorted or not, it will always take n log n time. So this statement is false. Now let's take a look at statement 2, bubble sort. We'll have a better look at bubble sort here. So what we do in bubble sort is, starting from the first element in the array, we'll be looking at each adjacent elements in the array, and if a of I is greater than a of I plus 1, we'll be swapping a of I and a of I plus 1 like this. If this element is greater than this element, we'll be swapping this. This we keep on doing for, after that we'll be doing it for a of 2 and a of 3, after that we'll be doing it a of 3 and a of 4. Likewise, we'll keep on doing it till the end of the array in one iteration. So what happens at the end of that iteration is, the largest element in the array will reach at the rightmost end. After that, we'll start the second iteration from the start of the array to the second last element of the array. After that, and we'll be doing this same swapping procedure. After that, the second largest element will be reaching at the second rightmost position in the array. After that, we'll again do the same procedure in the next iteration, only that this time we'll be doing it from the start to the third last element in the array. This we keep on doing. After that, the array will be sorted. Now that is how bubble sort works. But after each iteration of this swapping, if we count the number of swaps made during that iteration, and if that count is 0, then we can stop the procedure there itself, because after one iteration, if the number of swaps made is 0, which means it will mean that each element will be less than or equal to the element to the right side. Now if each element in an array is less than or equal to the element to the right side of the array, that means the array is in sorted order. So if you take a look again in an iteration, count the number of swaps made during that iteration, and if that count is 0, we can stop bubble sort procedure there itself, as the array would already be sorted. Now this particular step, in some textbooks, in the normal implementation of bubble sort, this particular step won't be there, but in some textbooks this particular step will be there. So in some textbooks, if we are including this, they call it modified bubble sort, but in some textbooks, even without calling it modified bubble sort, they will include this and they'll call it bubble sort only. So if this step is included, we'll see that if the array is in sorted order, it won't need any more iteration. It will need only one iteration to find out that the array is in sorted order, and it will stop there. So if we include this particular step, complexity of bubble sort will become theta n if the array is sorted. If this step is not included, then the complexity of bubble sort will be theta n square. But in this question, for our consideration, so we don't know which they are considering, though we will keep this in hold. We will look at statement 1. Quicksort runs in theta n square time. So in normal implementations of quicksort, we take the rightmost or the leftmost element as the pivot element. Sorry, this made a mistake here. In normal implementations of quicksort, we take the rightmost or the leftmost element in the array as the pivot element. So if we are doing that, then and if the array is in sorted order, then the complexity of quicksort will become theta n square. Now this is not. So if you are taking the rightmost or the leftmost element as the pivot element in quicksort, if the array is sorted, that quicksort runtime will become theta n square time. That is the worst case running time of algorithm. So for this question, we will consider this as correct. In that case, we can consider this bubble sort as the modified bubble sort only, which will include this, which will mean that the bubble sort can run in theta n time, meaning that saying bubble sort runs in theta n square time is false. So the correct answer is 1 and 4, that is option D. The Floyd-Warshall algorithm for all pair shortest path computation is based on A. Greedy paradigm, B. Divide and conquer paradigm, C. Dynamic programming paradigm, and D. Neither greedy nor divide and conquer nor dynamic programming paradigm. So this is a question from algorithm section. It's a very straightforward question regarding Floyd-Warshall algorithm. Now Floyd-Warshall algorithm is used to compute all pair shortest paths in a graph, and it is well known that it is based on dynamic programming paradigm. So the right answer is C. If you don't know about Floyd-Warshall algorithm, please refer to the video lectures and learn about it. This is a question from data structures topic regarding linked lists. So the question text was very large. I have written the summary of the question here. If you want to refer to the full question text, please refer to the question paper. So I will explain the question here. In the question, they are given us that there are n items stored in a sorted doubly linked list, and consider two operations, delete or decrease key operations. For these two operations, they are saying that a pointer is provided to the record to be deleted or modified respectively. Now on this linked list, we are performing theta n deletes, theta log n inserts, theta log n finds, and theta n decrease key operations. If that is the case, what is the maximum, what's the time complexity of all these operations put together? So we are performing these many operations, and they are asking us to find out what would be the time complexity if we are performing all of these together. Now they have given us a doubly linked list here. So if we want to delete any node in a doubly linked list, if we have the address of that node, then from that node only I can find out the address of the node to the left of that node and to the right of that node easily. And after that I can just remove the node, and then based on the address of these two nodes, I can make this node point to this node and this node point to this node. So in that manner I can perform delete in O1 time, which means that delete operations take O1 times. Now let's look at find operations. Even though the linked list is in sorted order, we will need O(n) time to find an element in the linked list, because we have to start from the first node and then keep on going on each element one by one until we find the node which we are looking for. Unlike in an array, we can't use binary search or any such methods since it is a linked list. Okay, so find will take O(n) time. Now insert operations will also take O(n) time. For insert, first we need to find out where in the single list we have to do the insert operation. Now that find will take O(n) time, and after that insert we can do in O(1) time once we find out the position where we need to insert. So insert in total will take O(n) time. Now decrease key operation again will take O(n) time. For decrease key operation, first the pointer of the key will be provided, pointer of the node will be provided. So I have this node, I have to perform decrease key, so I can easily decrease the key in the node in O(1) time. But then after that I need to maintain that it's a sorted doubly linked list. So I will need to change the position to the left or right after I decrease a key, so that the linked list will be in sorted order only. Now that change in position will again take O(n) time. So decrease key in total will take O(n) time. Now let's look at these operations. We are performing theta n deletes, that is theta n into each delete is taking O1 time, that is On into O1, plus theta log n inserts, that is O log n into each insert was taking On time, plus O log n finds, that is O log n into On, because find was On. Then theta n decrease keys, that is On into decrease key operation takes On time into On. So the total is big O of n plus big O of n log n plus big O of n log n plus big O of n square. Now we are adding all these, meaning we can take the one with the largest complexity, that is big O of n square. So O of n square is the answer, that is option C. The number of states in the minimum sized DFA that accepts the language defined by the regular expression 0 plus 1 star, 0 plus 1, 0 plus 1 star is dash. So this is a question from theory of computation topic regarding DFAs and regular languages. So this is the language given to us here. It says that initially we can have any number of zeros or ones. After that we need at least one 0 or 1, and after that we can have any number of zeros or ones. So this language means it will accept any string which has at least one 0 or one 1. Meaning it accepts a language having at least one element. So this we can rewrite it as 0 plus 1 plus, that is first we should have any 0 or 1, after that we can have any number of zeros or ones. Now the DFA for this language 0 plus 1 plus would be, initially we have a starting state. Now this is not an accepting state because this language will not accept epsilon. After that, on seeing 0 or 1 we go to the accepting state, and on seeing further zeros or 1 we remain in the same state. So this DFA has only 2 states. So the answer is 2. This is the DFA accepting this language. Language L1 is defined by the grammar S1 gives A, S1 B or epsilon. Language L2 is defined by the grammar S2 gives A, B, S2 or epsilon. Consider the following statements. P, L1 is regular, Q, L2 is regular. Which of the following is true? And 4 options are given. So this is a question from theory of computation regarding regular or context-free languages. So here we'll take a look at these two grammars and find out what the languages L1 and L2 actually are. So if you take a look at S1, S1 can give epsilon initially, or S1 gives A, S1 B. The same S1 can again give A, S1 B, etc. It will keep on going until S1 will resolve to epsilon and it will stop further resolutions. Which means that if you take a look here, L1 is same as the set of all strings, so A raised to n, B raised to n, such that n is greater than or equal to 0. That means it has equal number of A's and B's. There are n number of A's at the start, and after that n number of B's. Now this is a clear context-free language. A language like A power n, B power n, in order to equate the number of B's to the number of A's, we need to count the number of A's first. But n can be any large number, so it will need infinite amount of memory, so it is not a regular language. This is a context-free language. So saying that L1 is regular is false. Now we look at the second grammar. S2 gives A, B, S2. Again the same S2 can give A, B, S2. This will keep on producing A, B's in this manner until S2 get resolved to epsilon, and it will stop further productions. So this language is nothing but L2 gives set of all strings A, B the whole raised to n such that n greater than or equal to 0. Which means there can be n number of A, B's coupled together. Now this is a regular language. It can be expressed by the NFA given here. The starting state is an accepting state. On seeing A we go to this state, and on seeing B we go to the same accepting state. Now this NFA is the one accepting this language, and this is meaning this is regular. So statement Q is true. So from the options, option C is the correct answer. P is false and Q is true. Consider the following types of languages: L1 regular, L2 context free, L3 recursive, L4 recursive enumerable. Which of the following is or are true? 1. L3 complement union L4 is recursive enumerable. 2. L2 complement union L3 is recursive. 3. L1 star intersection L2 is context free. 4. L1 union L2 complement is context free. And 4 options are given here. So this is a question from theory of computation regarding closure properties of various languages. So we'll rewrite these languages complement and clean closure used here and find out what kind of languages these are. So L1 star, what is L1? L1 is a regular language. So L1 star is also a regular language because regular languages are closed under clean closure. So L1 star is regular. Now L2 is context free, but L2 won't be context free. L2 need not be context free because context free languages are not closed under complementation. But since L2 is context free, we can write L2 is recursive as well. So L2 is recursive as well, and recursive languages are closed under complementation, which means that L2 complement, what we can say for sure is that L2 complement is recursive for sure. Now L3 complement, L3 is recursive language. Again, taking complement of a recursive language will give us a recursive language only because recursive languages are closed under complementation. So L3 complement is recursive. Now we'll look here. L3 complement union L4 is recursive enumerable. Now L3 complement is recursive, which we found out here. L4 is recursive enumerable. Now the union of a recursive and a recursive enumerable language will be recursive enumerable language only because recursive enumerable languages are closed under union. So this statement is correct. 2 L2 complement union L3 is recursive. Now L2 complement, we know that it is recursive. Recursive union L3 is also recursive language. Recursive union recursive will be recursive only because recursive languages are again closed under union. So this is also true. 3 L1 star intersection L2 is context free. Now L1 star is a regular language, we know. L2 is a context free language, it's given in the question. Now intersection of a regular language with a context free language will be context free only. Now so saying that L1 star intersection L2 is context free is true. So this statement is also correct. Now 4 L1 union L2 complement is context free. Now L2 complement, we know that we can only say it is a recursive language. A recursive language union L1 is a regular will be a recursive language only. So we can't say for sure that L1 union L2 complement will be context free. So this statement is false. So looking at options, you will see that option D is the right answer. So in this question I have used various closure properties of all the languages. You need to learn all the closure properties regarding various languages, which is given in the video lectures for theory of computation section. So please refer to that to learn about this. Match the following. This is a question from compiler design topic. 4 options have been given on the left hand side and we need to match it to the appropriate ones on the right hand side. So we'll go through these one by one. One is lexical analysis. Now in lexical analysis phase, we know that we use regular expressions in order to match for tokens. So we can match P to regular expressions. Now Q, top-down parsing. During top-down parsing, from the options here you can see we use leftmost derivation. So Q we can match to 1 here. R, semantic analysis, type checking. Yeah, in semantic analysis phase we perform type checking. We perform that types are correct. We check that in the grammar, that meaning of the grammar is correct, that is type checking falls in that. So semantic analysis we match it to 2, type checking. R, runtime environments and activation records. Yeah, now we can match these two. Activation records are what we push to the stack when we are calling a function, right? So the options are P, the right answer is P3, Q1, R2, S4, that is option B. In which one of the following page replacement algorithms is it possible for the page fault rate to increase even when the number of allocated frames increases? A, LRU, B, optimal, C, MRU, and D, first in first out. So this is a question from operating systems regarding page replacement algorithms. In particular, they are asking us about Beladi's anomaly here. So what Beladi's anomaly states is that in some algorithms, some page replacement algorithms, even if we increase the number of page frames, the number of page faults which occur may increase. Now Beladi's anomaly occurs in non-stack based algorithms such as FIFO, first in first out, second chance algorithms, random algorithms, etc. Now what Beladi's anomaly is and what stack based algorithms are, what is stack property, etc. To learn about these, please refer to the video lectures to understand more. So from looking at the options, we can clearly see that FIFO is mentioned there. So option D is the answer, which we can answer directly. But for this question, I will show one particular case where this condition of page fault is increasing even when we are increasing the number of page frames that occurs. That is Beladi's anomaly occurring. So let us say these are the pages reference 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, 5. Now initially let us say we only have 3 page frames. Okay. Now we'll have 1, 2 and 3 added. So in the first case I have marked the page faults with a black X on top of these numbers. So for 1 it won't be there, 2 it won't be there, 3 it won't be there in memory. So for 1, 2 and 3 there will be a page fault since these are the first reference. Now we will be referencing 4 here, meaning we will swap out 1. This is first in first out algorithm. Okay, so we will swap out algorithm, add 4 which will cause a fault here. Now we are referencing 1 here which will cause another fault. We will strike out 2 and add 1. Again we are referencing 2 which is now not there, so we will add 2 by removing 3. Again another page fault here. Now we are referencing 5. Again 5 is not there, that will cause another page fault. Now in the page frames we have 1, 2 and 5. Now we are referencing 1 which is already there. We are referencing 2 which is already there. Now we are referencing 3. Now 3 is not there, so we will remove 1 and add 3. That's causing another fault. We are referencing 4. So 2 will be removed and 4 is added. That's causing another fault. Now we are referencing 5 which is already there. So if you count, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 page faults if we have 3 page frames and we are using first in first out algorithm. Now if we have 4 page frames, let us see what happens if we are using FIFO. Now for 1, 2, 3 and 4 it is first reference, so it will cause 4 page faults. I marked it with a red X here. 4 page faults occur. After that we are referencing 1 again which doesn't cause any page fault. We are referencing 2 again which doesn't cause any page fault. After that we are referencing 5. Now 5 is not there in our frame, so we will add 5 by removing 1. Now if you see, we are referencing 1 which got removed just now, so we will add 1 again which is causing another page fault and remove 2 which we are referencing again here. We will be removing 2 and adding 3 which we are referencing again here. We will be removing 3 and adding 4 which we reference again here, so we will have to remove 4 and add 5, etc. Keep on going. So all of these will also cause page faults as I have shown here. So the number of page faults will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So initially when we had 3 page frames we only had 9 page faults, but now we have 4 page frames and we are having a greater number of page faults, that is 10. This is Beladi's anomaly, and just now I showed that FIFO can cause Beladi's anomaly. So option D is the right answer. B plus trees are considered balanced because 4 options are given here. So this is a question from B plus trees coming from DBMS topic. So in B or B plus trees, one property is that all the leaf nodes in such trees will be at the same level. In B and B plus trees, all the leaf nodes will be at the same level, meaning the distance from the root node to each leaf node will be equal. So let's look at the options. A, the length of the path from the root to all leaf nodes are equal. So clearly this is true based on the property of B or B plus trees. B, the length of the path from the root to all leaf nodes differ from each other by at most 1. That's not correct. They don't differ, they are all equal. C, the number of children of any 2 non-leaf sibling nodes differ by at most 1. Even that's not true. Any internal node, if the order of a B plus tree is, let us say P, then any internal node can have number of children between P and P by 2. So saying that they differ by at most 1 is also false. The number of records in any 2 leaf nodes differ by at most 1. Even that is false. If the order is P, then an internal node then a leaf node will have number of records between P and P by 2. So even option D is wrong. So the only right answer is option A. Suppose a database schedule S involves transactions T1 up to Tn. Construct the precedence graph of S with vertices representing the transactions and edges representing the conflicts. If S is serializable, which one of the following ordering of the vertices of the precedence graph is guaranteed to yield a serial schedule? And 4 options have been given. So this is a question coming from DBMS topic regarding serializability of transactions. So if you don't know how to draw the precedence graph for transactions and then find out the serial schedule from there, please refer to the video lectures in order to learn how to do that. So we'll take a look at this question. Suppose we have 4 transactions which is given by the precedence graph T2, T3, T1, T4 in this manner. So this means that in the serial schedule, T2 should appear before T3 and T1, and T3 should appear before T4, and T1 should appear before T4. So for this there are two serial schedules, that is T2, T3, T1, T4, or T2, T1, T3, T4. So this transaction can be serialized to one of these serial schedules. So this is nothing but what is given by the topological ordering. So if you take a look at the options, topological order will give these two options. So this may be correct. Depth first search is wrong, because if you take depth first search in this, it will give T2, let us say it takes T3, and after that it will take T4, and only after that it will come back and give us T1. So T4 can appear before T1 in DFS, which is wrong. So saying depth first order is wrong. If you look at option D, ascending order of transaction indices, that is T1, T2, T3, T4, clearly that's also wrong because T2 has to appear first in this. So D is also wrong. Now BFS will also give same transactions for this particular precedence graph. But if you take a look at a precedence graph like this, this is not serializable, because T1 has to appear before T2, T2 has to appear before T3, and T3 has to appear before T1. So there is no topological ordering for this kind of precedence graph. But if we take BFS, we can get anything. If we start from T1, we will get T1, T2, T3. If we start from T3, we get T3, T1, T2. If we start from T2, we will get T2, T3, T1, etc. So BFS exists for this, but topological ordering does not exist for this, which means that BFS is also wrong, because for this one there is no serial schedules which can be converted to this. This can't be converted to any serial schedule. So only topological ordering is the correct answer. Anarkali digitally signs a message and sends it to Salim. Verification of the signature by Salim requires A. Anarkali's public key, B. Salim's public key, C. Salim's private key, and D. Anarkali's private key. Now this is a very straightforward question coming from computer security regarding digital signatures. Now how digital signature works is, if I have a message and if I need to digitally sign it, what I will do is, I will take the message and I will obtain a hash of the message to get a smaller message digest, and I will encrypt this message digest using my private key. Now this message and the encrypted hash of the message, I will send it to someone, so that someone can decrypt the digitally signed document using my public key, and he will get back the hash of the message, which he will verify it with the original message and verify that it was signed by me only. Now since only I have my private key, only I can sign it, and since everyone in the world will have my public key, anyone in the world can decrypt it using my public key and verify that it was signed by me only. So coming to this question, here it is saying that Anarkali is digitally signing a message and sending it to Salim. Means what Anarkali is sending is the message M, and also she will take the hash of the message H of M, and then she will encrypt it using Anarkali's private key. Now this only Anarkali can perform, because it is private key of Anarkali which only Anarkali has. Now she will send it to Salim, and at Salim's end he will receive the message just like it is. He will also receive this encrypted hash of the message, which he will decrypt it using Anarkali's public key, which when he decrypts it, he will get back the hash of the message. Now this hash of the message and the message, he will compare and verify that this hash is for this message only, and if that is true, he can verify that it was signed by Anarkali only. Now for performing this, what Salim needs is Anarkali's public key, which is given in option A. Option A is the right answer. In an Ethernet local area network, which one of the following statements is true? And 4 statements are given here. So this is a question coming from computer networks regarding CSMA CD in Ethernets. So CSMA CD, how it works in Ethernet is, every station in Ethernet will keep on sensing the channel until someone else is transmitting. So a station will keep on sensing the channel until the channel is free, and once the channel is free, a station will transmit. Now while transmitting, if some collision occurs, that station has to detect that collision, and it will send a brief jamming signal to notify all the stations that some collision has occurred. And after the jamming signal is complete, stations will retransmit again, following the binary exponential backoff algorithm to reduce future collisions. Now we will look at the options here. Option A station stops to sense the channel once it starts transmitting a frame. Now, this need not be true. A station can keep on sensing the channels in order to detect collision or for other reasons. Now, saying that a station stops to sense the channel once it starts transmitting is false. B. The purpose of the jamming signal is to pad the frames that are smaller than the minimum frame size. Now, this is false. The purpose of the jamming signal is to notify all the stations in case of some collision happening. Now, option C, a station continues to transmit the packet even after a collision is detected. Now, this is also false. A station, once it detects a collision, it will stop its transmission and it will send the jamming signal. Now, D, the exponential back-off mechanism reduces the probability of collision on retransmissions. Now, this is true. Ethernet uses exponential back-off algorithm to reduce probability of collisions in the future. Now, among these, only D is the right answer. Identify the correct sequence in which the following packets are transmitted on the network by a host when a browser requests a web page from a remote server, assuming that the host has just been restarted. And 4 options are given. In each of the options, there are 3 operations. One is HTTP GET, second is DNS query, and another one is TCP SYNC. So they are asking in which of the options these 3 have been given in the right order. So this is a question from computer networks. Now, when a host uses a browser to request a web page from a server, what happens first is, we should perform the DNS query to get the IP address of the server. Only once we know the IP address of the server, we can start communicating with the server. So the DNS query will happen first. After that, TCP SYN will be happening. That's for establishing a TCP connection with the server. And once both that is done, once both of those is done, the web browser can request HTTP GET in order to get web pages from the server. So the right order is 1 DNS query, 2 is TCP SYN, and 3 is HTTP GET request. So looking at the options, that is option C. So option C is the right answer here. A binary relation R on n cross n is defined as follows: A, B related to C, D if A less than or equal to C or B less than or equal to D. Consider the following propositions. P, R is reflexive, Q, R is transitive. Which of the following statements is true? And 4 statements have been given here. So this is a question from set theory. Here we have given this particular relation R, which states that A, B is related to C, D if A is less than or equal to C or B is less than or equal to D. Now let's take a look at the first statement. Statement P saying that R is reflexive. Now for any element A, B, that element is related to itself. A, B is related to A, B itself. That's because A is less than or equal to A is true and B less than or equal to B also is true, and any one of these had to be true in order to this to be related to this. So clearly any A, B we take, that is related to itself. So this relation is reflexive. So R is reflexive is true. Now let's take a look at Q. R is transitive. Now if you consider this, 1, 3 is related to 2, 0 since 1 is less than or equal to 2. Here 1 is less than or equal to 2. This satisfies this condition, A less than or equal to C condition. Similarly, this one 2, 0 is related to 0, 1. That's because this 0 is less than or equal to 1. This satisfies the condition B less than or equal to D. So 2, 0 is related to 0, 1. But 1, 3 is not related to 0, 1 because 1 less than or equal to 0 is false. Similarly, 3 less than or equal to 1 is also false. So clearly we have a counter example to show that this relation is not transitive. So Q is false. So looking at the options, P is true and Q is false. Option B is the right answer here. Which one of the following well-formed formulae in predicate calculus is not valid? We have been given 4 formulas here and we need to find out which one is not valid among these. So this is a question from propositional logic. Now we will try to go through these statements one by one and see which of these is not valid. The first one says that for all x, P of x implies for all x, Q of x. That will imply there exists x negation of P of x or for all x, Q of x. Now looking to the first part, for all x, P of x implies for all x, Q of x. This is of the form A implies B. Now A implies B we can write in the form of negation of A or B as well. So this A implies B, we can write it as negation of A or B. So negation of this part is for all x P of x, the negation of that is there exists x such that negation of P of x. That is negation, there exists x such that negation of P of x. What this means is that there exists x such that for which P of x is false. Here what this means that for all x P of x is true. Now this one's negation was there exists x negation P of x, or this part we'll write it straight here for all x Q of x. Now this is same as writing A implies B implies negation of A or B, meaning this one is correct. The statement is correct. Okay. Now we look at B. There exists x such that P of x or there exists x such that Q of x implies there exists x such that P of x or Q of x. What this says here is that if there exists x for which P of x is true, or there exists x such that Q of x is true, which means that for some value of x there is at least one of these will be true, which meaning that either there will be at least one value for which P of x is true, or there will be at least one value of x for which Q of x is true. Now if there is at least one value of x for which P of x is true and there is at least one value of x for which Q of x is true, we can definitely say that there will be at least one value of x for which P of x or Q of x is true. Now that is same as written here. So see, let us say for x equal to 3, let us say P of x is true. Now for that value, for x equal to 3, we can definitely say that P of x or Q of x is true, because P of x is true for that particular value which we took. So this implies this is also correct. Now looking at option C, there exists x such that P of x and Q of x implies there exists x P of x and there exists x such that Q of x. Now here it is saying that there is at least one value of x for which both P of x and Q of x is true. Let us say for x equal to 3, again P of x and Q of x both is true, which will imply that there exists x P of x is true, because at value of x equal to 3 we have this as true, and there exists x such that Q of x is also true, because at the same value we know that there exists x such that Q of x will also be true, that value is given as x equal to 3 because we took x equal to 3 the same value here. So saying that this implies this is also correct. C is also true. Now looking at option D, for all x P of x or Q of x implies for all x P of x or for all x Q of x. Now this is not true. I will show you an example to show that this is not true. Let us say P of x means P of x says that x equal to 1. So P of x will be true if x is 1, otherwise it will be false. Now let us say Q of x says that x is even. So Q of x will be true if x is even, otherwise Q of x will be false. And let us say x ranges in values 1, 2, 4 and 6. Okay, so this is the domain. Now for all x P of x or Q of x will mean for all x either P of x is true or Q of x is true. That means for all x either x is 1 or x is even. That is what Q is. Now that satisfies for all x. For 1 x is 1 is satisfied. For 2, 4 and 6 x is even is satisfied. So for this case, saying that for all x P of x or Q of x is true. Now they are saying that if this is true, that implies for all x P of x or for all x Q of x is true. Now this is false. What is for all x P of x? For all x P of x means for all x equal to 1. Now that is false, because for 2, 4 and 6 P of x will be false. Now again looking at this part, for all x Q of x, again that is also false. It says that for all x is even. Now if you can clearly see there is one x equal to 1 which is not even. So this part is also false. So this implies this is not correct. And they were asking which of the formulae in predicate calculus is not valid, meaning option D is the right answer. Consider a set U of 23 different compounds in a chemistry lab. There is a subset S of U of 9 compounds, each of which reacts with exactly 3 compounds of U. Consider the following statements. 1. Each compound in U by S reacts with an odd number of compounds. 2. At least one compound in U by S reacts with an odd number of compounds. 3. Each compound in U by S reacts with an even number of compounds. Which of the following statements is always true? And 4 options are given here. So this is a question coming from graph theory, and here what they are saying is that initially we have a set U of 23 different compounds. From there we are taking a subset S of U of 9 compounds, and each of which reacts with exactly 3 compounds of U, and they are asking us what will be the number of and they are asking about the set U by S. Now the set U by S is nothing but the elements in U after removing the elements in S, where S was a subset of U. So S contains 9 elements, U contains 23 elements. Now this S is subset of U, so U by S is the elements in U except the elements in S. So that there will be total of 23 minus 9, that is 14 elements there. Now there in each statement they have given some statement about the elements in U by S. In one it is saying that each element in U by S reacts with an odd number of compounds. In second they are saying each element in this set at least one compound in this set reacts with an odd number of compounds. Or 3, each compound in this set reacts with an even number of compounds. They are asking which of these is true. Now let us say this is set S. Set S contains 9 elements as shown here. Then suppose this is the set U by S, which is the elements in U after removing the elements in S. Now there will be 14 compounds here as shown here. Okay. Now they are saying that each compound in S reacts with exactly 3 other compounds. That 3 other compound may come from S or may come from this set U by S. That we will find out how it happens. So saying that a compound reacts with some other compound, we can denote it by adding an edge between that compound and the other compound. Okay. Now each element reacts with exactly 3 other compounds, right? So from each node in S there will be exactly 3 edges going out like this. Each compound reacts with 3 other compounds, so we can add exactly 3 edges for each node in S. Now the degree of each node in S will be the number of edges coming to that node, right? So since each compound in S reacts with exactly 3 compounds, we can say that degree of each node in S is 3. So that's important to note. Degree of each node in S is 3. So sum of the degrees of all the nodes in S will be 3 into 9, that is 27. So sum of the degrees of all of these nodes, these 9 nodes, is 27. But we know that in a graph, sum of the degrees has to be even, since each edge will be connecting 2 vertices, right? So it will add 1 degree to the left vertex and it will add 1 degree to the right vertex. So sum of the degrees is nothing but 2 into number of edges, which has to be always even. But sum of the degrees of nodes in S is 27, which is odd. So in order to make it even, we should add some degrees coming from some nodes in this set. So what we are effectively saying here is that we can't just form a graph by putting edges among the vertices in this set alone. If we do that, we should get a sum of degree of even, but after calculating we are getting that sum of degrees of nodes in S alone is 27, which is odd, which is not even. So in order to make it even, we have to add some degrees coming from some nodes in this set, and the sum of degrees of the nodes in this set has to be odd, because if this is even, an even number plus an odd number will never be even. So sum of the degrees of vertices in this set has to be odd anyway. If sum of the degrees of all the vertices in this node is odd, it means that there is at least one node which has an odd degree in this set. If all the nodes were having an even degree, then the sum of the degrees of the nodes in this set would have become even. But we know sum of the degrees of the nodes in this set is odd, which means at least one node in this set will have an odd degree. If one node has an odd degree, that means it reacts with an odd number of compounds. So that is statement 2. At least one compound in the set U by S reacts with an odd number of compounds. Option 2 is the right answer, that is option B. The value of the expression 13 power 99 mod 17 in the range 0 to 16 is dash. So this is a question from engineering mathematics regarding modular arithmetic. So we know Fermat's theorem. Fermat's theorem states that a raised to p minus 1 congruent 1 mod p if p is prime. So in the question we are taking mod with respect to 17, which is a prime number. So we can say that 13 power 16, 16 is 17 minus 1, will be congruent 1 mod 17, which is nothing but saying that 13 power 16 mod 17 will be equal to 1. Now in modular arithmetic, we should know that a into b mod something will be mod c will be equal to a mod c into b mod c the whole mod c. Now this statement is also true. Now 13 power 99 mod 17, we can rewrite it as 13 raised to 16 the whole raised to 6, that is 13 power 92 into 13 power 7 whole mod 17. Now this part we can split and write 13 power 16 the whole raised to 6 mod 17 into 13 power 7 mod 17 the whole mod 17 using this theorem here. Now 13 power 16 mod 17 is 1. So 13 power 16 the whole raised to 6 mod 7 will also be 1 only. So this I can rewrite it as 1 into 13 power 7 mod 17 whole mod 17. This we can easily find using a scientific calculator. This value will be 4. So the answer is 4 mod 17, that is 4 only. Suppose the functions f and g can be computed in 5 and 3 nanoseconds by functional units uf and ug respectively. Given the 2 instances of uf and 2 instances of ug, it is required to implement the computation f of g of x of I for 1 less than or equal to I less than or equal to 10. Ignoring all other delays, the minimum time required to complete the computation is dash nanoseconds. So in this question we need to compute the value of f of g of x of I for I ranging from 1 less than or equal to I less than or equal to 10. Okay, and they are given us that we have 2 functional units uf and ug, where uf will calculate function f for whatever we are inputting. If we are inputting x to this unit uf, it will output f of x. Similarly we have ug as well, to which if we are inputting x, it will be outputting g of x. So you can think of these as some hardware which is dedicated to calculate f of x and g of x respectively. Okay, and they are given that we have 2 instances of uf as well as 2 instances of ug. Cool. Now let us try to find out how much time it will take to calculate the values for 10 of these. So here we have 10 x values, right? x1, x2, x3 up to x10. And for calculating f, first we need to calculate the value of g of x of I. Only after calculating g of x of I can I start calculating f of x of I. Okay, and also x1, x2, x3, x4, etc. for each of the x values I can calculate this value independent of any other x values. x2's value won't be depending on x1. So I will start in this way. I will start calculating the g values one by one, that is g of x of I, that is, so first I will calculate g of x1, then I will calculate g of x2, g of x3, g of x4, etc. up to g of x10, and after that we will be calculating f of g of x1, f of g of x2, etc. So let us see how we can do that in minimum amount of time. So we have 2 instances of ug, right? So simultaneously I can start calculating g of x1 and g of x2, which I have written here. See, this white rectangle denotes the functional unit ug and this black rectangle denotes the functional unit uf, imagine. So I will start calculating g of x1 and g of x2 parallelly, since we have 2 instances of the functional unit ug, right? So x1 and x2 will finish calculating gx1 and gx2 in 3 nanoseconds. That was given in the question. This unit takes 3 nanosecond time and this unit takes 5 nanosecond time. So after 3 nanoseconds time I have g of x1 and g of x2 values available with me, which means that at that time only I can start calculating f of g of x1 and f of g of x2, which I have shown here. So initially I will be running ug to calculating g of x1 and g of x2, and once its value is available I will start calculating f of gx1 and f of gx2 in this way. So ugs I will be calculating parallelly without depending on ufs, which I have shown it like there. Here I am calculating gx1, gx2. Once it is done, it will take 3 nanoseconds. After that, we will calculate g of x3. Here we will calculate g of x4, etc., which will also take 6 nanoseconds. In a similar manner, in 15 nanoseconds, I will be calculating the entire g values, that is g of x1, g of x2, etc., up to g of x10. Now at this point, g of x1 and g of x2 were available, so parallelly we start calculating f of gx1 and f of gx2 here. Uf also we had 2 instances, so simultaneously we can start calculating f of gx1, f of gx2 here. This will take additional 5 nanoseconds time, so in total 8 nanosecond time this will be done. At this point you can see we have gx3 and gx4 values ready, so we can calculate f of gx3 and f of gx4 values simultaneously at this point, which will take additional 5 nanoseconds. So after this, again gx5, gx6 values will be available, so we can just keep on calculating f values in a similar manner. So calculating all of these will take, we are running it 5 times, 5 into 5 nanoseconds, that is 28 nanoseconds, plus there was an initial 3 nanosecond time for calculating gx1 and gx2. So the total time it will take is 25 plus 3, that is 28 nanoseconds. Consider a processor with 64 registers and an instruction set of size 12. Each instruction has 5 distinct fields, namely opcode, 2 source register identifiers, 1 destination register identifier, and a 12-bit immediate value. Each instruction must be stored in memory in a byte-aligned fashion. If a program has 100 instructions, the total amount of memory consumed by the program text in bytes is dash. So this is a question coming from computer organization's topic regarding machine instructions. So in the question they have given us that we have an instruction set of size 12, meaning that the opcode part of the instruction, we need to represent 12 instructions there. So for 12 instruction we will be needing 4 bits. That is because 2 power 3 is less than 12, but that is less than 2 power 4. So if we have 4 bits, we can represent 12 instructions correctly. Now we have 3 register fields, that is 2 source register field and 1 destination register field. Now there are 64 registers in total, that is 2 power 6 registers. So for representing each register we will need to allocate 6 bits. So each register field will be having 6 bits. Now in the question they are given there is an immediate value as well, which has 12 bits, that is given in the question directly. Now let us see what the size of each instruction will look like. So each instruction will be having an opcode part of 4 bits, source register part of 6 bit, source register part of 6 bit, destination register part of 6 bits, and immediate value that has 12 bits. So total that is 34 bits for each instruction. But in the question it is clearly given that each instruction must be stored in memory in a byte aligned fashion. Byte aligned fashion means that each instruction should be having an integer number of bytes. So if you take a look at it, it is 4 bytes is 32 bits and 5 bytes is 40 bits. 34 bits is not a correct whole number of bytes. So in order to make it byte aligned, we will need to allocate 6 more bits as well to make it 40 bits, so that it will be 5 bytes. We can't use 4 bytes because 4 bytes will be 32 bits, but each instruction need at least 34 bits. So each instruction will be taking up 5 bytes in order to make it byte aligned, meaning 100 instruction will be taking up 500 bytes. 500 is the answer. The width of the physical address on a machine is 40 bits. The width of the tag field in a 512 KB 8-way set associative cache is dash bits. So this is a question coming from computer organization topic regarding set associative caches. If you don't know about various types of cache such as direct mapped cache, set associative caches, or associative caches, please refer to the video lectures to learn about them and also to understand how to solve questions coming from them. So this is a very straightforward question coming from set associative cache topic. So a set associative cache will have address which looks like this. The first part will be block offset, and after that there will be a part associated with the set number. So these many bits will indicate which set number that particular address belongs to, and the remaining part will be having a length of log to the base 2 of k. Now log to the base 2 of k is when the cache is k-way set associative. Now how we got this, please refer to the video lectures to understand that. Now our cache is 512 KB, right? That is 2 power 19 bytes, which means that the length of this part, the address, will be 19 bits. Now this length will be 19 bits, meaning this part will be 3 bits because this is log to the base 2 of k, where k is 8, that will mean 3 bits, which means that this part comprising of the set number plus the block offset size, that will be 19 minus 3 equal to 16 bits, this part. So this is how the cache address looks like. Now coming to the physical address, this part will be common for address in the cache as well as a physical address because it is block offset plus the set number. Now that will be common for whatever address, and only the rest of the part will be the tag field in the physical address. Okay, so mapping this to the physical address, you will see that this much part takes 16 bits. So the initial 16 bits from the physical address will be reserved for denoting this block offset plus the set number part, and the rest of the part will be the tag field. Now we know that physical address is a total of 40 bits. The first 16 bits will be, the last 16 bits will be for block offset plus set number, which means the rest of the part, that is 40 minus 16, that will be the number of bits required for the tag field. So the answer here is 40 minus 16 is 24. Now you could have answered this using the direct formula as well. If you learn the video lectures, take a look at the video lectures, you will see that tag bits in a k-way set associative cache is log to the base 2 of main memory size divided by cache size into k. This was the direct formula. Even that also you could have applied here and got the answer directly. Consider a 3 GHz processor with a 3-stage pipeline and stage latencies T1, T2, T3, and such that T1 equal to 3 T2 by 4, that's equal to 2 T3. If the longest pipeline stage is split into 2 pipeline stages of equal latency, the new frequency is dash gigahertz, ignoring delays in the pipeline register. So this is a question from computer organization's topic regarding pipelining. So they are saying that initially we have a 3-stage pipeline system having latencies T1, T2, T3, which satisfies these equations, and after that we are splitting the longest stage into 2 stages of equal time, and they are asking what will be the new frequency of the processor. So they haven't given us what the time for T1, T2 and T3 are exactly, but they have given us that these 2 relations happen. One is T1 equal to 3 T2 by 4, also T1 equal to 2 T3. This is what we know. So let us try to assign some value to T1, T2, T3 which will satisfy this equation. Okay, let us say T1 is 6, T2 is 8 and T3 equal to 3. This is in some time unit. We don't worry about what the time unit is. We don't have to worry about that now. So if you see T1 equal to 3 T2 by 4, that is satisfied. 6 is 3 by 4 times 8, and also T1 equal to 2 times T3, that's also satisfied here. 6 equal to 2 into 3. So these values for T1, T2 and T3 satisfy the equation given here, and also if we assign it some random time, some time unit, we can make it satisfy this as well, saying that it is a 3 GHz processor, right? But we don't need to worry about that now. So if these are the latency for these 3 stages, the longest stage here is T2 having time 8. So cycle time will be 8 in some time unit, okay? Because cycle time depends on the longest stage here. Now after the modification, we are splitting the longest stage into 2. So here the longest stage is T2 taking time 8. Now if you are splitting that into 2 equal parts, the new stages will be T1 having time 6, T2.1 having time 4, T2.2 having time 4, T3 having time t. So these are the 2 new stages of size 4 and 4 instead of this one stage of size 8. Now if you take a look here, the longest stage here is T1 having time 6. Now the cycle time will be T1. Cycle time always has to be the delay of the longest stage in pipeline. So here the cycle time will be 8. So if you take a look here, we have reduced the cycle time from 8 to 6, which means that the improvement we got in the new system will be this cycle time divided by this, that is 8 by 6. This is the improvement that we have got now. Now we can compare it to that initial, this part of the data given here, that the initial one had a 3 GHz frequency. So if you have an improvement of 8 by 6, the new frequency will be 3 GHz into whatever improvement we got, that is 8 by 6, that will be equal to 4 GHz. So 4 is the answer in this question. A complete binary min heap is made by including each integer in 1 to 1023 exactly once. The depth of a node in the heap is the length of the path from the root of the heap to that node. Thus the root is at depth 0. The maximum depth at which integer 9 can appear is dash. So this is a question from data structures regarding min heap, in which they are saying that we are constructing a min heap containing 1023 elements, that is each integer between 1 and 1023 exactly once, and they are asking what is the maximum depth at which integer 9 can appear. So in all possibilities of constructing a min heap, what is the maximum depth at which integer 9 can appear? That is the question. So let's try to construct a binary min heap. Okay, so a min heap of one node will be at depth 0 only. That's what I have written here, 1 comma 0. This is number of nodes and this is the depth. If a min heap having two levels like this, it will have a depth of 1. Here this is a depth 0, this is a depth 1, and there will be 3 elements, that is 1, 2, 3 nodes, right? Now a min heap of having 3 levels will be having 1, 2, 3, 4, 5, 6, 7, that is nodes 1 to 7, there are 7 nodes, and the maximum depth will be 2, that is from root to here the path is 2. 2 is the maximum depth. Similarly, if we keep on extrapolating this, we will see that a min heap having 1023 elements, the maximum depth will be 9. This you can just keep on expanding this till we get 1023. So in our min heap, the maximum depth at which any node can appear is 9. Now let us see if our integer 9 can appear at a depth of 9. Okay, so maximum possible depth is 9. Now let us say at some point we have our node 9 like this. Okay, now the parent of this node has to be less than 9, right? This has to be some number between 1 to 8. Okay, let us say we take 5. Now the parent of 5 has to be less than 5 only. So parent of this can be any number from 1 to 4 only, right? So let us say we are taking 2 only. In that case, the parent of this has to be less than 2. So there is only one possibility, 1, right? So if we have to maximize the depth of 9, we need to choose numbers from 1 to 8 in a descending order in order to assign each one's parent. That's what I have done here. Let us say node 9 is at some point. So the parent should be less than 9. We'll take the largest number less than 9, that is 8. Now 8 can have a parent as 7, 7 can have a parent as 6, 6 can have a parent as 5, 4, 3, 2, 1. So this is the best way in which 9 can get the maximum depth. So if you take a look here, 9 is at depth 8 in this question. That is 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the best possible depth for our integer 9. Now we just construct a min heap taking this as one subtree in this manner. So let us try to let's try to see if we can construct a min heap like this way. So if we have 1 as a root node, 2 is the left child. Okay, we have taken up numbers from 1 to 9. The next one can be 10. So yeah, if you can see, we can just keep on adding numbers in the increasing order and we can fill up the subtree following that min heap's condition. Min heap's condition is that the root node should be having a value less than the value of its children. So this way it is possible that we can assign 9 in this manner, and after that we can construct the min heap also completely without an issue. So this is the best possible depth for 9, that is depth 8. This is a programming question. In this they have given us a particular function which computes x power y for positive integers x and y. That function is given here. After that they are asking which one of the following conditions is true before every iteration of the loop. 4 conditions are given here. Now they are asking which of these conditions will be true before every iteration of this while loop. So now let us try to find out the values of result a and b before each iteration of the loop, and let us see which of these options will be correct. So initially x equal to 5 and y equal to 3, and in the code first we are assigning result equal to 1, a equal to x and b equal to y. So the variable result is 1, a equal to x, that is 5, b equal to y, that is 3. Now what we are doing is, in the while loop if b is not equal to 0, when b becomes 0, that's the exit condition. If b is not equal to 0, if b percentage 2 equal to 0, a equal to a into a, b equal to b by 2. Else result equal to result into a, b equal to b minus 1. Now if b percentage 2 equal to 0 is nothing but checking whether b is even or not. So if b is even, we will be doing this, otherwise we will be doing this. So initially b is odd here, okay. So we will be coming to this part where result will be equal to result into a and b will be equal to b minus 1. So we will do result equal to result into a, 1 into 5 is 5, a remains the same, b becomes b minus 1, that is 2 here, okay. Now again we will be going through the loop. If b percentage 2 equal to 0, we are doing b is even, so that becomes true. We will be doing a equal to a into a, b equal to b by 2. So this was a here. A will become a into a, that is 5 into 5 or 5 square, and b will be b by 2, 2 by 1, that is 1. And result will remain same here, no change. Again we will come to the loop. This time b is odd since b is 1. So what we will do is result equal to result into a and b equal to b minus 1. So result is 5. 5 into 5 square will be 5 cube. And b will be b minus 1, b is 0. Now b is 0, exit condition is satisfied. We will be returning the value of result, that is 5 cube. So we can see we have successfully computed x raised to y, that is 5 cube here. Now let us see which will be true before every iteration of the loop. A, x power y equal to a power b. Now this is false because x power y will always be constant at 5 cube. But a power b keeps on changing here. See, a is 5 here, b is 3 here, so a power b is 5 cube here. But here it is 5 square, here it is 5 square, etc. So this is false. Option B, result into a power y equal to result into x power b. Okay, we'll check that also. Result into a power y will change as result into a power y. That is, initially it will be 5 cube, then it will be 5 square cube, then it will be 5 cube cube, then it will be 5 raised to 5 cube, etc. It keeps on increasing like that. But result into x power b will be, result is 1, 1 into x is 5, 5 cube, 5 square cube, 5 square cube, 5 raised to 4 cube. That is result into x power b. Oh, I'm sorry, I was saying result into x power b. So 5 into 1 power 3, that is 5 cube, 5 square raised to 2, 5 into 5 is 5 square raised to 1, 5 raised to 4 raised to 0, that is 1. So clearly we saw that this was keeping on increasing, but this is going on decreasing. So these two values are also not same. Now option C, x power y equal to result into a power b. X power y is always 5 cube, right? Now we will do result into a power b, what that is. Here it is 1 into 5 cube, that is correct. 5 into 5 square, that is 5 cube, again that's also correct. 5 into 5 square raised to 1 is 5 square only, that is 5 cube, again that's also correct. 5 cube into 5 square raised to 0, that is 5 square raised to 0 is 1, that is 5 cube only. So in this case we saw that this condition was satisfied for each of the examples we took here. This condition is satisfied. So C seems to be right. Let us verify D also. X power y equal to result into a power b. Now x power y is always 5 cube. Let us say result into a the whole raised to b. So result into a will be 5 the whole raised to 5 cube, that is correct. 5 into 5 is 5 square. The whole raised to 2 is 5 raised to 4. So that is wrong. It had to be 5 cube. So option D is also false. So C is the only correct answer here. Consider the following new order strategy for traversing a binary tree. First, visit the node, then visit the right subtree using new order, and then visit the left subtree using new order. The new order traversal of the expression tree corresponding to the reverse Polish expression 3 4 star 5 minus 2 power 6 7 star 1 plus minus is given by, and 4 options have been given. So this is a question from data structures regarding binary tree traversal. So in binary trees we know in order, pre-order, post-order traversal, etc. In the question they are giving a new type of traversal. They are calling it new order strategy, and they have told us what exactly to do in new order strategy. Now for a given reverse Polish expression given here, they are asking what will be the new order traversal from among the options. Now what is reverse Polish expression? Reverse Polish expression notation that will take left subtree first and then right subtree and then root. So that is reverse Polish expression. Okay, so based on this here, let us try to construct the tree if this is the reverse Polish expression. So in reverse Polish we know it first it will take left, then right subtree, after that root. So if we have something like 3 4 star, we can say that 3 will be the left tree, right will be the 4 will be the right subtree, and then star will be the root. So I will draw it like this: 3 4 and then star as the root. Now after this much part you will see it is this part and then 5 and then the operator minus, meaning this is the left subtree, 5 is the right subtree, and minus is the root, which I have drawn here. 5 minus, like this. Again after this we have this part, then 2 and then power operator. So that will be drawn like this. This is the left subtree and then 2 comes in and then this power operator here. Now after this we are seeing two numbers together, and then after that one operator, meaning 6 will be the left subtree of the star and 7 will be the right subtree of the star, and star will be the root. So we will be starting a new tree here: 6 7 and star, like this. Okay, and after that again we have this part and then 1 and then plus, meaning this is the left subtree, 1 is the right subtree, and then we have plus, which I have drawn like this here. Okay, now then we have two expressions together and then minus, meaning this is the left subtree, this is the right subtree, and this is the root, which I have drawn like this. So this is the tree for the expression given here. Now we will try to find out what will be the new order traversal of this tree. So in new order traversal, you know, first we will print the root value and then we will visit the right subtree, and after that we will visit the left subtree. So we will print minus first, after that we will print the values in the right subtree, and then we will print the values in the left subtree. So the new order traversal I have given here, first it is minus, after that we come to this part. Here again we will print the root first, that is plus, and then we will print 1, and then we will come to this part. Here we will print star first and then 7 and then 6, like this, and then we comes to this part. So we will be printing power 2, and then we will be printing minus and then 5, and then we will come to this tree, we will print star and then 4 and then tree. That's what I have given here. So looking at options, minus plus 1 star 7 6, minus plus 1 star 7 6, yeah. Option C is the right answer. That gives what I have written there. This is a C programming question here. They have given us this particular code snippet and they are asking the value printed by the program is dash. We need to find out what the value would be that is printed by this program. So let's take a look at this program here. So in the main function we are declaring an integer array of size 5, that is 3 5 2 6 4. So the array will look like this: 3 5 2 6 4, and A is the name of the array, meaning A will be pointing to the starting address of the array. Okay, and then we are printing %d, which will be the return value of the function f a comma 5. Now we are passing A to this pointer P. Now A and P will be the same thing because A was the starting address of the array here, right? So P will also be now contain the same address as the starting address of this array, which means that A and P are now pointing to the same array only. They are pointing to the beginning of the array. Now if P is pointing to the beginning of the array, P plus 1 will also be a pointer pointing to the first element of the array. P plus 2 will point to the second element of the array, etc. Now let us look at this function. To the function we are passing the array and an integer n. Now we see n is 5 here, so n is the size of the array. So an array and the size of the array we are passing here. If n is less than or equal to 1, return 0, else return max of f p plus 1 comma n minus 1 or comma p of 0 minus p of 1. Now let's take a look at this function here. In the question they are given us that max xy returns maximum of x and y. So calling this function will return the maximum of the value of this function, again called recursively with a different set of parameters, and the value of p of 0 minus p of 1. It will return the maximum of these two. Okay. Now let us see how this function will proceed. So initially we are calling the function with the starting address of the array as a of 0, where p was pointing to a of 0 and n was 5 initially, meaning that the array indices, the range of the array was starting from array a of 0 up to a of 4. The array of size 5 like this was passed initially, and then we are returning maximum of this function called again, comma, p of 0 minus p of 1. Now what happens when this function f is called again? When f is called again with a new pointer p plus 1. Now p plus 1 will be a pointer pointing to the first element in the array, and n is being passed as 5 minus 1, that will be 4 here. So essentially we are passing, initially to the function we are passing this array of size 5. Now we are passing this array of size 4, since n became 4 and the starting address also became this. So essentially second time when we are calling the function, we are passing this particular array. Now when we are passing this array, again it comes here and then it will compute the maximum of, again that function is being called recursively, comma, p of 0 minus p of 1. Now what is p of 0 minus p of 1? In the first function we are calling f, we passed f p plus 1 to this function. Now this is passed by value, which means that when the second time this function is running, the p value will be pointing to this one, since p plus 1 from the first call was passed to p in the second call of the function, meaning in the second call of the function, that is where we had this array, p is pointing to the starting address of the first element, or the starting address of this element 5. So in this function when we are doing p of 0 minus p of 1, it essentially means this element minus this element. Now this was actually p of 1 in the original function, right? So I will just write it like this. It is again calling max f with p of 1 minus p of 2 here. Now again we are calling this function recursively, and this time we are passing this pointer, whatever p we had, that plus 1. Essentially we will be passing this pointer only to the third iteration, to the third call of the function, okay? And n will be again reduced by 1, so 4 minus 1 will be 3. So essentially in the third time when we are calling, we will be passing this particular array to that function, and in that p of 0 minus p of 1 will essentially mean p of 2 minus p of 3 in that original array, original full array we have. So which means first we are passing the entire array 0 to 4, we are calculating max of f, comma, p of 0 minus p of 1. Inside this f we are passing the array 1 to 4, and we are calculating max of again f, comma, p of 1 minus p of 2. Inside this function we are passing the array 2 to 4, and we are again calculating max of f called again, comma, p of 2 minus p of 3. Inside this we are again passing the array 3 to 4, and we are again doing max of f, comma, p of 3 minus p of 4. And inside this function we are passing the array 4 to 4. Basically we are only passing this one element. So at that point n will become 1. So if n is less than or equal to 1, the return value will be 0. So at this point we will directly return 0 from the function f, which means coming back to this function, the value here will be 0, comma, p of 3 minus p of 4. Okay, maximum p of 3 minus p of 4 is 6 minus 4, that is 2. So the maximum of these two will be 2. That 2 will be passed to this function. So here we got 0, and this was 2. Maximum of 0 and 2 is 2 only. So coming to this part, the value returned will be 2. P of 2 minus p of 3 is minus 4. Maximum of 2 and minus 4 is 2 only. So coming to this function, the value returned here will be 2 only. P of 1 minus p of 2 is 5 minus 2, that is 3. Now the maximum of 2 and 3 will be 3, which is returned here. They will have 3. P of 0 minus p of 1 is minus 2. Max of 3 and minus 2 is 3. Now that will be returned at this point. Now that's the final return value, which is 3. 3 is the answer. Let A1, A2, A3 and A4 be 4 matrices of dimensions 10 by 5, 5 by 20, 20 by 10 and 10 by 5 respectively. The minimum number of scalar multiplications required to find the product A1, A2, A3, A4 using basic matrix multiplication method is dash. So this is a question coming from algorithm section regarding matrix chain multiplication. Now if you have two matrices, let us say A1 and A2, of dimensions a1 having 10 by 5 and a2 having 5 by 20, then the number of scalar multiplication that it will need will be 10 into 5 into 20. If it's at 10 by 5 and 5 by 20 matrix, if you are multiplying, the scalar multiplications are, number of scalar multiplications are 10 into 5 into 20. And also the final matrix a1 a2 will be having a dimension of 10 into 20. Okay, so using this information we'll try to find out which is the chain that minimizes the number of scalar multiplications required. So if we need to find out a1 a2 a3 a4, there are 5 matrix multiplication chains possible. One is a1 a2, first we multiply together, then we multiply to a3, and then we multiply that to a4, or we multiply a1 and a2 together, then we multiply a3 and a4 together, and then these two we multiply at the end, or we multiply a2 and a3 first, to that we multiply a1, and to that we multiply a4, or a2 and a3 we multiply first, to that we multiply a4, and to that we multiply a1, or the fifth possibility is a3 and a4 we multiply together, to that we multiply a2, and to that we multiply a1. These are the only 5 possibilities if you are multiplying 4 matrices. Now for each of these 5 possibilities we will calculate the number of scalar multiplications required, and then we will find out the minimum. So in the first case we are multiplying a1 and a2. So these are the dimensions of a1, this is dimension of a2, 10 by 5, 5 by 20. So total scalar multiplications will be 10 into 5 into 20, that is 1000. Now the final matrix will have a dimension of 10 by 20 here. Now to this we are multiplying a matrix a3 of dimension 20 by 10. So that will add the number of scalar multiplications as 10 into 20 into 10, that is 2000. Now that matrix will have a final dimension of 10 into 10. To that, if I am multiplying a4, I will get 10 into 5 multiplications, that is 500. So a total of 3500 scalar multiplication will be required if you are using this chain. Similarly, for each of the chain, I have calculated the value here. If you are multiplying like this, a1 a2 will add 1000, a3 a4 will add 1000, and at the end multiplying these two will add another 1000, which will give 3000. Similarly, in this chain a2 a3 will give 1000. To that, if you are multiplying a1, it will add 500. To that, if you are multiplying a4, it will add 500. Total will be 2000. In this case, a2 and a3 when multiplied will give 1000. To that, if you are multiplying a4, it gives only 250. To that, if you are multiplying a1, it gives only 250. So total is 1500. And if you are multiplying using this chain, a3 a4 gives 1000. To that, multiplying a2 will give 500. To that, multiplying a1 will give 250. Total of 1750. So clearly the minimum in all these 5 is 1500 when we are using this particular chain. So the answer is 1500. The given diagram shows the flowchart for a recursive function an. Assume that all statements except for the recursive calls have O1 time complexity. If the worst case time complexity of this function is big of n power alpha, then the least possible value of alpha is dash. So this is a question regarding solving recurrence relations. Now in this question they have given us that we have a particular recursive function an, and this is the flowchart for an. Now let's try to calculate the time complexity of an. So in this flowchart, if you see, there are 4 particular paths that we can take. The paths are, we can take this path, or we can take this path, or we can take this path or this path. Now if you are taking this path, it will be calling a of n by 2 2 times, and in this path it's calling a of n by 2 3 times. In this path it's calling a of n by 2 4 times, and in this path it's calling a of n by 2 5 times. Now to calculate the time complexity of this function, we need to take the worst path that it can take, which will give us the maximum time complexity, that is this path. Now this path has how many a of n by 2's? It is 1 2 3 4 5. So this is the worst case time complexity of the function when it is always taking this path. So the recurrence relation for this function a of n, I can write it like this: a of n will be equal to 5 times a of n by 2 plus f of n, where f of n is the time complexity of the rest of the parts. apart from these a of n by 2 statements, what other statements are there? It's the time complexity of that. Now in the question it's given that except for the recursive calls, it has O1 time complexity. So f of n will be a function having O1 time complexity. So if you take a look here, a of n equal to 5 times a of n by 2 plus f of n. Now this type of recurrence relation we can easily solve using the master theorem. Now if you don't know about master theorem for solving recurrence relation, please learn about that first. It will be helpful for solving many these kind of questions. So in master theorem, we can take this as A and this will be B. In master theorem, we are writing recurrence relations of the form T of n equal to A into T of n by B plus f of n. Now A is 5 and B is 2 here. So the complexity of this function will be big O of n raised to log A to the base B. That is the case 1 of master theorem. We can write it like this: if the function f of n has a time complexity less than O of n raised to log A to the base B minus epsilon. Please learn about master theorem in order to find out how I got that. So for this one, using case 1, I can write the complexity as big O of n raised to log A to the base B. That's equal to big O of n raised to log 5 to the base 2, that is n power 2.32. Now that is the value of alpha. 2.32 is the answer. The number of ways in which the numbers 1, 2, 3, 4, 5, 6, 7 can be inserted in an empty binary search tree such that the resulting tree has height 6 is dash. Note, height of tree with single node is 0. Now this is a question coming from data structures topic regarding binary search trees. Here they are asking, if you are inserting the numbers 1, 2, 3, 4, 5, 6, 7 into a binary search tree, how many tree we can form which will have a height of 6. Now if you are adding 7 numbers and forming a tree of height 6, it will mean that that tree will be a chain. A chain meaning none of the nodes will be having 2 children simultaneously. Each node will be having exactly 1 child only. So I will show you examples of chain. So if you are adding 1, 2, 3, 4, 5, 6, 7, if I am adding like this 1, then 2, then 3, etc. up to 7, that is one chain. Another example is if I add 7 first, then 1, after that 2, 3, etc. So in all of these, each node has exactly 1 child only. So these are examples of chains here. So they are asking how many will be there such that the height is 6. Now to solve this for n equal to 7, n equal to 7 meaning there are 7 numbers here. To solve this for n equal to 7, first I will try to solve this for smaller n values, and then I will try to find out patterns in trying to solve for larger numbers. Okay. So first we will try to solve for n equal to 2. That meaning we are adding numbers 1 and 2 only. Okay. So while we are adding numbers 1 and 2, there is only 2 ways possible. That is 1 we add and after that we add 2, or we add 2 after that we add 1. Both of these have height of 1 only. These are chains. So for n equal to 2, the answer is 2 clearly. Now for n equal to 3, coming here, I can add 1, 2, 3, or 1, 3 and then 2, or 3, 2, 1, or then 3, 1 and 2. These are the only 4 possibilities for n equal to 3. If I am adding 2 first, okay, initially if I am adding 2, then 1 will come to the left side and 3 will come to the right side. So that won't be forming a chain. The node 2 will be having 2 children and not 1 child. So the height will be 1 only here, height won't be 4 like in these 3 examples, like in these 4 examples. So for n equal to 3, the answer will be 2 only. Answer will be 4 only. Okay. So one pattern that we found out is that if you are adding numbers from 1 to n, the first number has to be either 1 or n only. If you are adding some numbers in between, then for that number we will have numbers to the left side as well as right side. So that is not a valid addition. I'll explain clearly here. For n equal to 4, let us say, I can start with either 1, the root node should be 1, or 4. If the root node is 3, imagine there will be 1 and 2 coming to the left side of 3 and 4 will come to the right side of 3. Similarly, if the root node I am adding as 2, if I am adding 2 initially, then 1 will come to the left side of 2 and 3 and 4 will come to the right side of 2. So if I am adding 1, 2, 3, 4, if I am adding 2 or while adding 1, 2, 3, 4, if I am adding 2 or 3 as the first element, then that won't form a chain. It will be having, the root node itself will be having 2 children. So while adding numbers 1 to 4, I can either add 1 or 4 only as the root node. Okay. Now after adding 1 as the root node, I can add 2, 3 and 4. Okay. And the number of ways of adding 2, 3 and 4 will be like solving the same problem for a tree with 3 nodes. That's what we did here exactly, n equal to 3, right? So if I'm adding 1, I can add 2, 3 and 4 in 4 ways, because for n equal to 3, a tree having size 3, I can add it in 4 ways. See, that's what I've shown here. If I'm adding 4 initially, then I can add 1, 2 and 3 in this way, this way, this way or this way. These 4 ways are exactly what we got here, 1, 2 and 3 this way, 1, 3, 2, that is given here, 1, 3, 2, 3, 2, 1, 3, 2, 1, 3, 1, 2, 3, 1, 2. Similarly, the same thing I can do it by adding 1 itself. I add 1 as a root node and then I add the rest of the 3 nodes in one of these 4 patterns. Similarly, for n equal to 3 also, if you take a look, I added 1 first and then I added 2 and 3 in the same fashion as I did for n equal to 2, or I added 3 first and then I added 1 and 2 in the same fashion as I did for n equal to 2. Similarly, if I am solving for n equal to 5, if n equal to 5, first I can add 1 and then I can add 4 nodes in either one of these patterns, that is 8 ways, or I could have added 5 initially and then I could have added 1, 2, 3, 4 in any of these 8 ways. So for 1 also we will have 8 ways, for 5 also we will have 8 ways. So for n equal to 5, the answer will be 16. So what we have got here is that we have found the recurrence relation for solving this problem. If a of n is the number of ways in which we can solve for a tree having n nodes, then the value of a of n will be equal to the value of a of n minus 1 into 2. That's what we did just here and we found out. So for n equal to 2, the value will be 2, which we did and we found out. For n equal to 3, the value will be 2 times of this, that will be equal to 4. And for n equal to 4, the value will be 2 times of 4, that is 8. 4 and 8, as you can verify, I have drawn the trees here as well. Similarly, for n equal to 5, the value will be 2 times of 8, that is 16. For n equal to 6, it will be 32, and for n equal to 7, it will be 2 times of 32, that is 64. So for our question, the answer is 64. In an adjacency list representation of an undirected simple graph G equal to V, E, each edge UV has 2 adjacency list entries, V in the adjacency list of U and U in the adjacency list of V. These are called the twins of each other. A twin pointer is a pointer from an adjacency list entry to its twin. If number of edges equal to m and number of vertices equal to n and the memory size is not a constraint, what is the time complexity of the most efficient algorithm to set the twin pointer in each entry in each adjacency list? And 4 options have been given for the complexity. So this is a question from data structures regarding graph. Here they are saying that for a graph we are having an adjacency list representation. That means for each edge u and v, first of all each vertex will have its own adjacency list entries, and then for each edge u and v will be added in u's adjacency list as well as u will be added in v's adjacency list. Now these 2 entries will be denoting the same edge only, so this will be called twin pointers. So in addition to having v in u's adjacency list, we'll also have the address of the entry u in v's adjacency list as well. I'll repeat that. Suppose I have u. In u I need to add the entry v. Similarly in v's adjacency list I need to add the entry u, and on top of that in u I have added v plus I need to add the address of u entry in v's adjacency list as well, meaning the address of this entry also I will be adding here. Similarly the address of this entry I will be adding here as well. So that's what they were saying, the twin pointer from an adjacency list entry to its twin. So we need to have a pointer from this entry to this entry as well as this entry to this entry. Now let's try to answer the question. Let us say I have a graph like this. Okay, it has 5 vertices, so there will be 5 adjacency lists, 1, 2, 3 and 5 for each of the nodes here. Now let us say I am starting BFS traversal in this tree. So I will start from node 1 here. I will see that it has edges to node 2, so I will be adding 2 in one's adjacency list. At the same time I will be adding 1 in 2's adjacency list as well. Now just now I added these 2 nodes, right, which means I have the address of these 2 nodes ready right now itself. So I can just add a pointer to each other in each of the entries like this. Okay, and then I will continue with BFS. from 1 we reached 2. After that we will be seeing 3, which means that in 1 I will be adding the entry 3, as well as in 3's adjacency list I will add the entry 1. Now just now I added these two entries, so I have pointers to it. I have the address of these two, so I can just easily add the pointers to each other right now itself. Okay. Now once edges are complete, after that I will be visiting 2. Now 2, 1 we already visited, so we won't be visiting it again. 2 has this edge 3, so in 2's adjacency list we will be adding 3, as well as in 3's adjacency list we will be adding 2. Now these two were added just now, so I will just add the pointer like this directly. So now you get the idea. I just do the BFS traversal, and each time I am adding one node in adjacency list, I'll be adding its twin also in its adjacency list, and then and there I'll be adding the pointer only. So this has the same complexity as doing BFS traversal, plus adding the pointer here and adding the twin pointer, etc. will take only O1 complexity. So this algorithm will have the same complexity as the complexity of BFS traversal. Now the complexity of BFS traversal is nothing but big of n plus m. So the answer will, for our answer, the complexity will be big of n plus m. Now looking at options, that is options B. They are given in theta notation, which is the same thing. B is the answer. Consider the following two statements. If all states of an NFA are accepting states, then the language accepted by the NFA is epsilon star. 2. There exists a regular language A such that for all languages B, A intersection B is regular. Which of the following is correct? 4 options are given here. So let's look at statement A. It says that if all states of an NFA are accepting states, then the language accepted by the NFA is epsilon star. Now take a look at this NFA here that I have drawn. Here this NFA will accept strings of the form A, epsilon, AB, ABB, etc. So clearly this NFA doesn't accept the string B, or any string starting with B, this won't accept. That is because in this state we don't have any production for the terminal B. Similarly, at this state we don't have any production for the terminal A. So saying that if all states of an NFA are accepting states, then the language accepted by NFA is epsilon star is false, as shown clearly here. Now if it was a DFA, then if it was a DFA and all states were accepting states, then it would have, we could have said that the language is epsilon star, because in DFA in every state there will be production for all the terminals. But it was asked about NFA here, so the statement is false. 2. There exists a regular language A such that for all languages B, A intersection B is regular. Now this is true. Phi is a regular language. Phi intersection any language will be phi only, meaning that phi intersection any language will be regular. So statement 2 is correct. In fact, if A was any finite language, then A intersection B also would be any finite language only. So if A was any finite language, then we could have clearly said that A intersection B is also regular. So we need not have taken phi. Any finite language will also work for statement 2. Now statement 2 is the only correct one, that is option B. Consider the following languages: L1 equal to A power n, B power n, C power n plus m, such that m n greater than or equal to 1. L2 equal to A power n, B power n, C power 2n, such that n is greater than or equal to 1. Which of the following is true? 4 options have been given. We need to find out which among these L1 or L2 is context free. Now if you take a look at language L1, that is clearly context free. Here we have to match C to the sum of the number of A's and B's. So that we can easily do with a push down automata. For each A's we will be pushing A's to the stack. On top of that we will be pushing all the B's also to the stack. Then on seeing every E, we will be popping off whatever is in the stack, A's or B's, whatever. So at the end, when C's are over, if the stack is empty, it will mean that A power n, B power n, C power n plus m will be satisfied. So C will be, the number of C's will be equal to the sum of number of A's and number of B's. So clearly L1 is context free. Now looking at L2, it is A power n, B power n, C power 2n. Now this is not context free. First of all, we have to match the number of A's and B's. So for that, matching the number of A's and B's we can do by pushing all the A's to the stack, and after that popping off A's for each B's seen. But then after that we need to match the number of C's also to the number of A's or B's as well. A power n, B power n, C power 2n, meaning we need to see that we have twice as many C's as there are A's or B's. So at the same time we need to compare C with the number of A's, compare C with the number of B's, and also we need to compare B's with the number of C's. All of these we can't do with using a single stack. In order to understand that better, please refer to the video lectures regarding context-free languages and context-sensitive languages. This is actually a context-sensitive language. So this is not context-free. Looking at options, that is option B, saying L1 is context-free while L2 is not context-free. Consider the following languages. L1 equal to set of all m such that m takes at least 2016 steps on some input. L2 equal to set of all m such that m takes at least 2016 steps on all inputs. L3 equal to set of all m such that m accepts epsilon, where for each Turing machine m, the encoding m denotes a specific encoding of m. Which of the following is true? And 4 options have been given regarding whether these languages are recursive or not. So this is a question coming from theory of computation from the topic recursive languages and Turing machines. Now, in order to answer this question, we need to have very good concepts about Turing machine, recursive languages, etc. So we'll go through these languages given here one by one and find out which of these are recursive. First of all, let us take the language L1. Now L1 is the set of all Turing machines which take at least 2016 steps on some input. So the set of all Turing machine is a countable infinite set. Okay. So given an encoding of a Turing machine, if we can find out whether m belongs to the language L1 or not, then we can say that L1 is recursive. So I'll repeat that. For any encoding of a Turing machine given, or basically any Turing machine given to us, if we can say whether that Turing machine belongs to this language or not, then we can say that this language is recursive, because in a decidable way we are finding out whether that belongs to this language or not. Now let us say we have been given this Turing machine m. Now I am designing a new Turing machine here which will check whether m belongs to L1. So if that Turing machine is a decidable one, that means it will halt for every input and find out that whether that Turing machine belongs to L1, then the language L1 is recursive. Okay. So what our new Turing machine will do is, it will take the input encoding m, take the Turing machine of that is it takes the Turing machine m, and then to that we will input all the strings of length less than or equal to 2016 and run it for a maximum of 2016 steps. That is, to this Turing machine m given to us, we will be inputting all the strings of length less than or equal to 2016 and run it for a maximum of 2016 steps. We are restricting this Turing machine to run only maximum 2016 steps. Okay. So all strings of length less than or equal to 2016 is a finite set. Let us say if the alphabet is, let us say A, B, C, then the strings of length 0 will be epsilon, strings of length 1 will be A, B, C, strings of length 2 will be A, B, A, C, B, A, B, C, C, A, C, B, etc. So all strings of length less than or equal to 2016 is a finite set. Okay. And for each of that finite number of strings, we are running the Turing machine for a maximum of 2016 steps only. Now there can be two cases. Case 1 is that for some input it ran for 2016 steps. It reached 2016 steps. When it reaches 2016 steps, we are stopping the procedure, right? So for some input it reached 2016 steps. What does it mean? It means that for some input this Turing machine is running for 2016 steps. What it means is, for at least some input this Turing machine is taking 2016 steps for some input, which means that this Turing machine will belong to the language L1. M belongs to L1. Now case 2 is, for all the inputs it halted before 2016 steps. That is, for all the input it didn't reach till 2016 step. Now in case 1, if it reached 2016 step, it doesn't mean that the Turing machine halted at that 2016 step. No, it doesn't mean that. We were restricting the Turing machine for till 2016 steps. So once it reaches 2016, we can say for sure that this Turing machine is running for at least 2016 steps. Now case 2 is that for all the inputs it halted before 2016 steps, which implies that for all the strings of length less than or equal to 2016, it will halt before 2016 steps. Now that will also mean one more important thing, that is, for all the strings of length greater than 2016 also, it will halt before 2016 steps. Why that is so is, all strings having length greater than or equal to 2016. For reading that string itself, we will need at least 2016 steps, correct? Now, all strings of having length greater than or equal to 2016, it will have a prefix of length less than or equal to 2016, right? Now, for that prefix only we were testing here, and for that prefix part only we are seeing that it is halting before 2016 steps. So we can say that for the strings of length greater than 2016 also, this Turing machine will halt before 2016 steps, which implies M does not belong to L1. So clearly I got two cases only. For the new Turing machine we designed, we will take the input Turing machine and we are running this on the Turing machine, and there are only two cases, either that Turing machine will belong to L1 or the Turing machine will not belong to L1. We will output that, and our new Turing machine decided it is not going into any infinite loop state. For every Turing machine we can easily decide whether that belongs to L1, which means that the language L1 is recursive. Yeah. Now let's look at the language L2. For this also we will be doing the same procedure as we did for L1 with a small variation. So for L2 we are trying to find out whether L2 is recursive, right? So for given encoding of a Turing machine M, just like we did previously, we need to find out if M belongs to the language L2. So what we will do is, again we are designing a new Turing machine. What that will do is, it will take the Turing machine M, which was the input, and to this Turing machine it will input all strings of length less than or equal to 2016 and run it for a maximum of 2016 steps, again just like the previous case. Now here there are two cases. One is, for some input it halted before 2016 steps, okay? Now if for some input it is halting before 2016 steps, then clearly it doesn't belong to L2. L2 is the set of all Turing machine that takes at least 2016 steps on all inputs. So if it is halting before 2016 steps, clearly that Turing machine M won't belong to the language L2. It was L2, sorry. Now case 2 is, for all the inputs it ran for 2016 steps. Now if for all input it is running for 2016 steps, for all strings of length less than or equal to 2016, we can say that for strings of length greater than 2016 also it will run for at least 2016 steps. That is because all the strings of having length greater than 2016, the prefix part only is what we have done here, that is all strings of length less than or equal to 2016. Now for the prefix part itself it is taking at least 2016 steps. So for all strings of length greater than 2016, reading that prefix part alone will take 2016 steps. So we can say that for strings greater than length greater than 2016 also it will be taking at least 2016 steps, which implies M belongs to the language L2. So it was just opposite of the previous case, right? So clearly there are only two cases. For any input Turing machine M, we can decide whether it belongs to the language L2 or not using the Turing machine which we designed now. So L2 is a recursive language because for any input we can decide whether that belongs to this language L2. So L1 and L2 are recursive here. Now looking at L3, it says that the set of all Turing machine which accepts the language epsilon. So here it is basically the set of all Turing machine that accepts the language epsilon, meaning for any Turing machine given we need to find out whether epsilon belongs to that language or not. Now this is not decidable. That's because for given a Turing machine, and if you are inputting epsilon to that Turing machine may run for infinite amount of time. We can't say whether it will run for infinite amount of time or not. It can run for infinite amount of time. It can go into a loop. So for epsilon given a Turing machine, we can't say whether that Turing machine will accept epsilon or not. So this language is not recursive actually. So looking at options, only L1 and L2 are recursive. So that is L1, L2 are recursive and L3 is not recursive. Option C. Which of the following grammars is free from left recursion? A. S gives AB, A gives AA or B, B gives C. Option B. S gives AB or BB or C, A gives BB or epsilon, B gives E. C. S gives AA or B, A gives BB or SC or epsilon, B gives D. Option D, S gives A or B or C. A gives B D or epsilon. B gives A E or epsilon. So this is a question from compiler design regarding left recursion in grammars. So if you have a context-free grammar and a production like this, a variable A which gives A itself and E. So if you see in the production, the first one itself is the same variable A. So these kind of production are called left recursions in that grammar. So the problem with left recursion is that if a grammar has left recursion, then top-down parsers can't parse such grammars. Or there is also one more example of left recursion, that is variable A giving variable B. That was fine, but then variable B gives A again. So A will give B, B will give A will give B, B will give A, etc. It keeps on going. So this is also left recursion. Now let's look at the options. If you look at option A, clearly here A gives AA. This is clearly left recursion. Similarly in option C, you can see that S gives AA and at the same time A gives SC. So this will keep on going on. S gives A gives S, S gives A, etc. So this is also a left recursion. In option D also we have the same thing. Variable A gives BD and B gives AD. So A gives B, B gives A. It keeps on going like that. So that's also left recursion. So option B is the right answer. You can verify that this doesn't have any such similar left recursion. A student wrote two context-free grammars G1 and G2 for generating a single C-like array declaration. The dimension of the array is at least 1. For example, int A of dimensions 10 and dimension 3 semicolon here. This is a sample array here. For grammar, use D as the start symbol and use 6 terminal symbols: int, semicolon, ID, left bracket, right bracket and num. Now the grammars G1 and G2 are given here. Which of the grammars correctly generate the declaration mentioned above? So we need to find out among these grammars G1 and G2 which of these will correctly generate arrays of this format. That's what we need to find out here. So we'll take a look at the grammars here. So let us look at grammar G1 first of all. G1 says that in G1 the variable D generates int, L and semicolon. Okay, that is given here. So already that int, starting int and the final semicolon we have already got there. Now only we need that array name and that dimension part. So let us see what L will generate. L generates ID, left bracket and E. So this looks like this. Okay. Now what will E generate? E generates, there are two productions for E. E will generate num right bracket, left bracket E or num right bracket. So if you take a look, we can keep on generating num right bracket, left bracket E's. This E will again generate num right bracket, left bracket E, etc. It will keep on going until some E generates num and right bracket and then closes that production part. So we can rewrite E as E will be generating num right bracket, left bracket star. That is 0 or 1 times num right bracket, left bracket star, and at the end num right bracket. Okay. So if this part is 0, what we'll get is int ID, left bracket, num, right bracket, semicolon. That is correct. It is a declaration of an array with 1 dimension. If this part is 1, then what we'll get is int ID, left bracket, num, right bracket, left bracket, num, right bracket, semicolon. So that's also correct. That is a declaration for an array of 2 dimensions. Similarly, how many times we generate this? Each time we generate it, only the dimension of the array will increase by 1. So this will be producing array declarations of dimensions 1, 2, 3, etc. and it will keep on going. So this is correct. Grammar G1 will generate arrays in the format that we want here. Now we look at grammar G2. Again here also D generates int L semicolon, which I have written here, int L semicolon. L will generate ID E. Okay, ID E. So we got int ID and the semicolon part correct. Now we just need that dimension part, that is left bracket, some number, right bracket. So let us see what E generates. E can generate 2 productions here. There are 2 productions for E here. E will generate E, left bracket, num, right bracket, or E will generate left bracket, num, right bracket only. So what it means is that E can keep on generate this part, E, left bracket, num, right bracket. That E will again generate E, left bracket, num, right bracket, etc. It will keep on going until some E produces this part, left bracket, num, right bracket, and at that point E's are over from the right hand side, so the production stops. So what it effectively means is that E will be generating left bracket, num, right bracket, star, and left bracket, num, right bracket. E will be generating productions in this format. So if this part is 0, star means 0 or 1 times this part. So if this part is 0, what it will generate is string int id left bracket num right bracket semicolon. That's also correct. That is the declaration of array of 1 dimension. If this part is 1, it will be int id left bracket num right bracket num right bracket semicolon. That's also correct. That is array of 2 dimension. In this way, the number of times we generate this part, it will be generating array of 1 dimension, 2 dimension, 3 dimension, etc. So this will also be generating our array declaration in the format we want. So both of these two are correct. There were 4 options in this question. Option was only G1 is correct, G2 is wrong. Option 2 was G1 is wrong, G2 is correct. Option 3 was both are correct. Option 4 was neither of them were correct. So as you can see, G1 and G2 both are correct, and that option saying both are correct is the correct answer here. Consider the following processes with the arrival time and the length of the CPU burst given in milliseconds. The scheduling algorithm used is preemptive shortest remaining time first. So we have these processes, the arrival time and the burst times. The average turnaround time of the processes is dash milliseconds. So this is a question from operating systems regarding process scheduling. So here we are using preemptive shortest remaining time first scheduling algorithm. To learn about various process scheduling algorithms more, please refer to the video lectures coming from operating systems section. Okay, so here we are using preemptive shortest remaining time first, which means that we have a set of process running, and at that time if some new process comes which has a shortest remaining time, shorter than the one which is currently running, then the one currently running will be preempted and the new one will be scheduled, since that will be having a shorter remaining time. So let's take a look at these processes and how it proceeds. So at time 0 we only have the process P1 here. So initially P1 will start running. So P1 will run from 0 to 3. Okay, at that time process P2 arrives. Now P1 has run for 3 bursts and it total had a 10 burst time. So there is remaining 7 milliseconds for process P1. But P2, when it arrives at time 3, it only has remaining 6 milliseconds. So P2 will have a shorter remaining time. So P1 will be preempted and P2 will be assigned the processor. So at time 3, P2 will start running. Now P2 proceeds, and when the time is 7, process P3 also arrives. And so at this point P2 has run from 3 to 7, meaning it has used up 4 milliseconds out of its burst time, and there was a total of 6 milliseconds, so the remaining burst time is 2 milliseconds. But now P3 also has arrived, and P3 has only 1 remaining time, only 1 millisecond remaining time, meaning at this point P2 will also be exempted and P3 will be allotted the processor. So at time 7 P3 starts running. Now P3 has only 1 millisecond, so at time 8 P3 will be over. At time 8 P4 also arrives, but it has 3 milliseconds burst time, and we know P2 only has 2 milliseconds remaining time at this point. So P4 won't be running, instead P2 will be running at this point. So P2 runs from 8 to 10. At that point P2 will also be over, and at this point we have P1 and P4. P1 has 7 milliseconds remaining, P4 has only 3 milliseconds remaining, so P4 will be allotted the processor. So at time 10 P4 starts running till time 13, and at time 13 P4 will be over. We only have process P1 left, it has 7 milliseconds left, so from 13 to 20 P1 will be running. So now we need to calculate the turnaround time. The turnaround time is the amount of time it took till the process got over, starting from when the process arrived. So if you see, P1 arrived at time 0 and it got finished at time 20, so the total time taken is 20 minus 0, that is 20. Similarly, P2 ran from 3 to 10, meaning turnaround time is 7. P3 ran from 7 to 8, so the turnaround time is 1. P4 ran from 8 to 13, so the turnaround time is 5. So the average turnaround time is 20 plus 7 plus 1 plus 5 by 4, that is 8.25. Consider the following two-process synchronization solution. Process 0, entry loop while turn equal to 1, critical section, exit condition, turn equal to 1. Process 1, entry condition, loop while turn equal to 0 in critical section, and exit condition, turn equal to 0. It's not equal to. The shared variable turn is initialized to 0. Which of the following is true? A. This is a correct two-process synchronization solution. B. This solution violates mutual exclusion requirement. C. This solution violates progress requirement. D. This solution violates bounded weight requirement. So this is a question coming from operating system section regarding process synchronization. Now, while designing process synchronization solutions, it has to satisfy these two primary goals. One is it should satisfy mutual exclusion, and two, it should satisfy progress. And then it can also satisfy the secondary requirements, that is bounded weighting and architectural neutrality. Now these two conditions it has to satisfy, otherwise it is not a solution. Now these two properties are optional. We can, if we have these two, then it is better, our solution is a better solution. If these two are also not there, also it is fine, still we can call it a synchronization solution. But these two are the ones we absolutely need. Mutual exclusion here means at any point two processes should not enter the critical section. Only one process should be able to enter the critical section. That is mutual exclusion. Now progress means if some process needs to enter the critical section, then some other process which is not planning to enter the critical section should not be controlling the process which wants to enter the critical section. So I'll repeat. Suppose let us say process 0 wants to enter the critical section, and let us say process 1 currently now doesn't want to enter the critical section. Then in that case, process 1 should not block or slow down process 0 from entering the critical section. Process 0 should be allowed to enter the critical section in such cases if process 1 doesn't want to enter. Now that is progress. Bounded weighting means any process should not be having to wait indefinitely in order to enter the critical section. That is, some process should not be starved from entering the critical section. That is bounded weighting. Architectural neutrality means our solution should work on any platforms irrespective of the operating system or the processor, etc. That is architectural neutrality. But these two are the ones which we absolutely need. So we will see if our solution satisfies these two conditions. Okay. Now what is our solution doing here? The entry condition is while entering, before entering the critical section, it will loop while turn equal to 1. So turn is a variable here. So if turn is 1, then process 0 won't be able to enter the critical section. But if turn is not 1, then process 0 will enter the critical section, because this while loop will be returning false. So it will exit from here, it will come to the critical section and it will execute the critical section, and after that while exiting it will make turn equal to 1. Now if you look at process 1, it will be looping while turn is equal to 0. While turn is equal to 0, it will keep on looping here, it won't be able to enter the critical section. But if turn is not equal to 0, then it will enter the critical section, and while exiting it will make turn equal to 0. Okay, so turn here changes between 1 and 0. So when turn is 1, only process 1 will be able to enter the critical section. After entering, it will make turn equal to 0, and when turn is 0, process 0 will be able to enter the critical section, and while exiting it will make turn equal to 1. So if turn is 0, only one process will be entering. Similarly, if turn is 1 also, only one process will be entering the critical section. So mutual exclusion condition is satisfied in our solution, because there is no way at some point both the processes can enter the critical section. But is progress there? Let us say turn is equal to 0 now. Okay, turn is equal to 0 now. Now if you see, while turn is equal to 0, process 1 won't be able to enter the critical section. It is blocked. Process 1 is blocked now. But process 0, if you see, process 0 will be able to enter the critical section. Okay. Now let us say process 0 doesn't want to enter the critical section. That is, it is not even reaching this point. Process 0 is executing something else. It doesn't want to enter the critical section now. But until turn doesn't become 1, process 1 won't be able to enter the critical section. So what it means is that if turn is 0, process 1 wants to enter the critical section, but it can't enter because turn is 0. And process 0 also doesn't want to enter the critical sections. It is doing something else. So process 1 needs to enter but it can't enter. Process 1 doesn't need to enter, it is doing something else, which means turn will not become 1 anytime soon. So it's like process 1 can't enter the critical section even though it wants, and there is no one else who wants to enter but still it is blocked. Now that means progress condition is not satisfied. Process 1 wants to enter, no one else wants to enter, but still process 1 can't enter. So progress condition is not satisfied. So we can't say that this is a proper synchronization solution. So if you look at option B, option C, this solution violates progress requirements. So option C is the right answer. Consider a non-negative counting semaphore S. The operation PS decrements S and VS increments S. During an execution, 20 PS operations and 12 VS operations are issued in some order. The largest initial value of S for which at least one PS operation will remain blocked is dash. So this is a question coming from operating systems topic regarding semaphores. So if you don't know about semaphores, I would recommend please refer to the video lectures and learn about it first before coming to the question. So in this question, we are performing 20 P of S operations. So P of S is nothing but down operation on the semaphore, and 12 V of S operation. V of S are up operations on the semaphore, increment operations. So we have 20 decrement operations, 12 increment operations, and they are saying what is the largest value of S for which at least one down operation will remain blocked. So if you see, we'll have P and V's etc. in some order. There will be 20 P operations and 12 V operations. So there will be 32 operations in some order. That order doesn't matter. Okay, and they are asking for, if we have it in some order, what is the largest value of S which will ensure that at least one P operation will remain blocked. So if you take a look here, for every P operation and one V operation, the total effect will be cancelled out. So what I mean to say is that here P will decrement the semaphore by 1, okay, and after a while if we have some V operation, that V will increment the value of the semaphore by 1. Similarly, if we have some V and then later some P is coming, similarly what happens here is that V operation will increment the semaphore, but this P will decrement the semaphore. So the total effect will be cancelled out. Similarly, if we have P and then V, then also the total effect will be cancelled out. The semaphore's value will remain the same. P will decrease, V will increase. Similarly here, V will increase, P will decrease. So if we have 20 P operations and 12 V operations, out of that 20 P operations will be, its effect will be cancelled out due to 12 V operations happening later. So this we can consider as 8 P operations alone. Okay. Now if we have 8 P operations only, if a semaphore's value is any value greater than or equal to 8, then this 8 P operations will go on executed unblocked, because for each P operation, that operation will be unblocked if the value of semaphore is greater than or equal to, if the value of the semaphore is greater than 0. So if, let us say I have 8 operations, then initially the value is 8, then after each operation the value will reduce by, initially it is 8, so it will become 7, 6, 5, 4, 3, 2, 1, 0. So only after all the 8 operations will the value become 0. If I have one more P operations coming in, then that one will be blocked. So if you have 8 P operations, if the semaphore value is 8, then none of those will be blocked. But if the semaphore's value is 7, then the first 7 P operations will be executed unblocked, but the last one will be blocked. So the largest initial value of the semaphore for which at least one P operation will be blocked is 7. A file system uses an in-memory cache to cache disk blocks. The miss rate of the cache is shown in figure. The latency to read a block from the cache is 1 millisecond and to read a block from the disk is 10 millisecond. Assume that the cost of checking whether a block exists in the cache is negligible. Available cache sizes are in multiples of 10 MB. The smallest cache size required to ensure an average read latency of 6 milliseconds is dash MB. So this is a question from computer organization regarding caches. So in the question, we need to find out the average read latency we have been given that the average read latency is 6 millisecond. In that case, what should be the miss rate of the cache? That's what we need to find out. So average read latency, how do we calculate it? So in the question they have given one point, that is assume that the cost of checking whether a block exists in the cache is negligible. So initially we will check whether some block we need is there in the cache or not. That cost is negligible. So after checking that, if it is there in the cache, then we will directly read it from the cache. If it is not there in the cache, we will read it from the disk block. Okay, so we can rewrite it as hit rate into cache read time. Whenever it is there in the cache, that is given by hit rate, that into cache read time, plus miss rate into disk read time. That is the average read latency. Now let us assume miss rate is m, then hit rate will be 1 minus m. So it will be equal to 1 minus m into cache read time was 1 millisecond, plus miss rate m into disk read time was 10 millisecond, that is 10. That is equal to 9m plus 1. Now in the question it's given that this is equal to read latency of 6 millisecond. This will be equal to 6, which will imply miss rate will be equal to 5 by 9. That is roughly 55%. Now in order to get 6 millisecond average read latency, the miss rate should be less than or equal to 55%. So if you look at the diagram here, in the y-axis they have given the miss rates, and in the x-axis they have given the cache sizes. So we found out that miss rate should be less than or equal to 55%. So 55 will be somewhere around here. Okay, now the miss rate has to be less than this, meaning miss rate should fall. This is 55, so miss rate should be in this range only. Now in this range, if you see, for this particular miss rate, the cache size was somewhere between 20 and 30. Okay, but in the question they have also given that available cache sizes are in multiples of 10 MB. So the smallest cache size larger than this in multiples of 10 MB would be equal to this one, 30 MB. So the answer here is 30. Consider the following database schedule with two transactions T1 and T2. A schedule is given here: R2 of x, R1 of x, R2 of y, W1 of x, R1 of y, W2 of x, A1, A2, where Riz denotes a read operation by transaction Ti on a variable z, Wiz denotes a write operation by transaction Ti on variable z, and Ai denotes aborts by transaction Ti. Which one of the following statements about the above schedule is true? It is recoverable, has cascading abort, does not have cascading abort, S is strict. So this is a question coming from DBMS regarding transactions topic. Here we have been given a particular transaction and we need to find out whether it is non-recoverable, recoverable with cascading aborts, or cascadeless, strict, etc. So to learn about these type of transaction, I would say please refer to the video lecture. The definition and explanation has been given there properly. So please refer to that to learn about this. So here I will give a refresh about these type of transactions. A non-recoverable transaction is one in which a dirty read happens. Dirty read means a transaction T1 writes some data and then T2 is reading that data written onto by transaction T1. So T2 is reading dirty data. Dirty data meaning data that is written onto by transaction, some other transaction. So if dirty read happens and the second transaction which is doing the dirty read commits before the first one commits or abort, this type of schedule is non-recoverable. Why that is non-recoverable is here T1 is writing some data, after that T2 is reading that data and then it is doing some modification and the transaction T2 is committing. But let us say after that T1 hasn't committed or aborted yet. Let us say T1 is aborting. So whatever data written onto by T1 will be reversed. But you can see that T2 already read that data, modified it and then committed also. So there is no way we can recover transaction T2. There's no way we can roll back transaction T2 here. So these type of schedules are non-recoverable. A recoverable schedule with cascading rollback is, in case of dirty reads, let us say T2 is reading data written onto by T1, commit only after the first one commits or aborts. So if T2 is reading data written by T1, T2 won't be committing till T1 either commits or abort. If T1 commits, fine, T2 can go on and commit it. But if T1 is aborting, then T2 2 also we can roll back now since T2 hasn't committed yet. So these are recoverable schedules with a cascading rollback. Now cascadeless schedule is that there are no dirty read happen in this. That is, if transaction T1 writes data, then some other transaction T2 can read data written onto by T1 only after either T1 commits or T1 aborts. So we won't be having to roll back transaction T2 in this case if T1 is aborting. Now strict schedules are those in which if T1 is writing some data, then that data cannot be either read or written onto by some other transaction T2 before T1 commits or aborts. These type of schedules are strict schedules. Now let us look at the schedule given in our question. Here transaction 1 is reading from X, transaction 2 is reading from X first, after that transaction 1 reads X, after that transaction 2 reads Y, after that transaction 1 writes X, transaction 1 reads Y, transaction 2 writes X, after that 1 and 2 both aborts. Now if you see, these are the conflicts that I have mapped here. So here transaction 1 is writing X, here transaction 2 is also writing X. Now after transaction 1 writes X, you can see that transaction 2 is also writing on the same data X before transaction 1 is aborting, meaning that the condition for strict schedules is not satisfied. For a schedule to be strict, if data written onto by T1 cannot be read or written onto by T2 before T1 commits or abort. But here data written onto by T1, that is X, is written onto by 2 as well before T1 commits. So this is not strict. Now if you see data writing happens here and here. Now there is no other transaction which is reading the data written onto by 1 or 2. So we can say that dirty read doesn't happen here. So this falls under this case. This is a cascadeless rollback, recoverable schedule with cascadeless rollbacks. Now what it means is that is option C. S does not have cascading abort. That's the correct answer. Consider the following database table named water schemes. We have this table water schemes, scheme number, district name and capacity are the columns. The number of tuples returned by the following SQL query is dash, and we have been given this SQL query. We need to find out the number of tuples returned by this SQL query. So if you look at the SQL query, it is using SQL with clause. What with clause does is, it will give this subquery block a name, that is total here, and this subquery block, whatever is written by the subquery block, it will be treated as a table having this name, and that can be referenced multiple times in the main SQL query, that is this select query here. So these two are with clauses here. These two will return some table with names as this. It's not exactly a table, but whatever is written will be treated as if it is a table in the main SQL query. So this will be treated as a table named total, and what this returns will be treated as a table named total average, that is referenced in the SQL query here. So we'll go through this now. With total name capacity as select district name sum of capacity from water schemes group by district name. So here we are running a select query. We are selecting district name and sum of capacity from water schemes. We are doing group by district name. So when we are grouping by district name, the sum of capacities will be for Ajmer it will be 20, for Bikaner it will be 10 plus 10 plus 20, that is 40, for Churu it will be 20 plus 10, that is 30, for Dungargar it will be 10 only. And whatever this is returning, we'll name it as a table total with columns name and capacity. That's given here, total, name and capacity. Now here this with clause, what it does is select average of capacity from total. So from this table total, we will just take the average of capacity, that is 20 plus 40 plus 30 plus 10 by 4, that is 100 by 4, that is 25. So this will be treated as a table named total average having column capacity, and there is only one entry, that is 25. Now we'll look at the main select clause. Select name from total average, where total dot capacity greater than or equal to total average dot capacity. So we are just returning the name of the districts from this table which has a capacity greater than 25, that is Bikaner and Churu only. So the final query will be returning two rows, one for Bikaner and one for Churu. So the total number of tuples returned by the SQL query will be 2. A network has a data transmission bandwidth of 20 into 10 power 6 bits per second. It uses CSMA CD in the MAC layer. The maximum signal propagation time from one node to another node is 40 microseconds. The minimum size of a frame in the network is dash bytes. So this is a question from computer networks regarding CSMA CD. Here they are saying that we are transmitting a packet from one node to another and we are using CSMA CD for collision detection. If that is the case, what should be the minimum packet size used in this network? So take this example here. Let us say node A is transmitting to node B. Okay. Now A starts transmission, so the signal starts propagating in this way. It goes through the channel and let us say at some point some collision happens. Okay. After this much time collision happened, meaning that information needs to now flow back to A. So that will flow back like this and it will go to A. So how much time did it take? The total time is this part plus this part. That's the total time it took for A to realize that there was a collision. Now the worst case time, the most time it can take is if the collision happens at the end of the channel. That is, collision happens, let us say, just before B. So for this much time the packet keeps on propagating through the channel. It reaches up to B and then some collision happened, so that information has to flow back to A. So the total time taken is the time taken from A to B plus the time taken from B to A. Now time taken from A to B is propagation delay, that is given as 40 microseconds here. So the maximum amount of time it can take for A to realize a collision has happened is 2 times the propagation delay. Okay. So A should be keeping on transmitting a packet till that much time at least. If the transmission time, let us say, was less than 2 times propagation time, imagine. So A is keeping on transmitting. After a while some collision happened and before this collision reaching A itself, A will have finished transmitting the packet. Now in that case, only after transmitting the packet A will realize that some collision happened. So in that case A won't be able to retransmit the packet. That should not happen. Before A finishes transmitting the packet, the collision information should flow back to A. The maximum time it can take for the collision information to flow back to A is 2 times propagation delay. So the transmission time of the packet should be at least 2 times the propagation delay. Only in that case A will get to know if a collision has happened before the packet finishes transmission from A. Now that means Tt greater than or equal to 2 times Tp. Transmission time is nothing but L by B, where L is the packet size and B is the bandwidth. So L by B greater than or equal to 2 times Tp, meaning packet size L greater than or equal to 2 into Tp into bandwidth. That's equal to 2 into propagation delay was 40 microsecond, that is 40 into 10 power minus 6 seconds into bandwidth was 20 into 10 power 6 bits per second. Now this 10 power minus 6 and 10 power 6 we can cancel out. So the total is 2 into 40 into 20 bits. That is 1600 bits or 200 bytes. The question they were asking the size of the packet in bytes, that is 200. For the IEEE 802.11 MAC protocol for wireless communication, which of the following statements is or are true? 3 statements I have given here and 4 options are also given. So this is a question from computer networks regarding Wi-Fi. IEEE 802.11 MAC protocol is nothing but Wi-Fi. So please refer to the video lectures to learn about Wi-Fi and its properties and how it works, etc. So we'll go through the statements one by one now. 1. At least 3 non-overlapping channels are available for transmission. Now this is true regarding Wi-Fi's. We have 3 non-overlapping channels. 2. The RTS-CTS mechanism is used for collision detection. Now RTS means request to send, CTS means clear to send. Now these are control frames which are used for collision avoidance in Wi-Fi. These are not used for collision detection. There is no collision detection in Wi-Fi. So saying that it is used for collision detection is false. Statement 3. Unicast frames are ACT. Now that's also true. In Wi-Fi every frames are ACT because there is no collision detection. So statement 3 is true. Now looking at options, that is option 1 and 3 only, that is option B. Consider a 128 by 10 power 3 bits per second satellite communication link with one-way propagation delay of 150 milliseconds. Selective retransmission protocol is used on this link to send data with a frame size of 1 kilobyte. Neglect the retransmission time of acknowledgement. The minimum number of bits required for the sequence number field to achieve 100% utilization is dash. So this is a very straightforward question from computer networks regarding SR protocol, that is selective repeat protocol. So to learn about SR protocol, please refer to the video lectures to understand that. So you need to understand how to calculate efficiency in SR protocol, and also to find out how many sequence numbers are required in SR protocol in order to answer this question. So based on that knowledge, efficiency in SR protocol is given as efficiency equal to n by 1 plus 2 into T propagation by T transmission, where n is the number of packets sent in one round and Tp is propagation delay, Tt is transmission delay, which will mean n will be equal to 1 plus 2 into Tp by Tt if we want to make efficiency equal to 100%. That is equal to 1 plus 2 into propagation delay was given as 150 millisecond, that is 150 into 10 power minus 3 seconds, divided by T transmission is packet size divided by bandwidth. Packet size is 1 kilobyte, that is 1024 into 8 bit, divided by bandwidth, that is 128 into 10 power 3 bits per second, 128 into 10 power 3 bits per second. Now this, when you simplify, you will get 1 plus 4.687, that is 5.687. Now the packets has to be an integer, that is less than or equal to 5.687, which will mean 5 packets that we are sending. So in each round we will be sending 5 packets. So in SR protocol, the number of sequence numbers required will be 2 times the number of packets we are sending in one round, that is 2 into 5, that will be equal to 10. So we need 10 different sequence numbers. Therefore the number of bits required in sequence number field will be 4 bits, because if you have 3 bits we can have 8 different numbers. For having 10 different numbers we need at least 4 bits in the sequence number field. So the answer is 4 here.